2, 1.
Hi folks, my name is Lauren Olja. Welcome to our very first one-of-a-kind telethon event. This is called Python from A to Z. And I am your host, Lauren Olja. Later on today, I will be joined by my co-host, Jane Harriman. You may know me from such antics as the PyData Global Pub Quiz or the the very first one of 2020, our very first PyData Global, or the executive co-chair of the, what was that? Of PyData NYC 2018 and 2019. Or you may know me as one of the organizers of NYC Python. And so I'm really excited to be here today to help raise money for NumFOCUS. NumFOCUS is a 501c3 nonprofit, global nonprofit dedicated to open science that is inclusive and reproducible. And so it's really important for the PyData ecosystem. That's the ecosystem of tools that we use for open source scientific computing. And so I just wanted to remind you that we are live. This is a live event. Anything can happen on live TV. My dog might run by or things like that. And we're really hoping to have a lot of fun here today. So without further ado, actually, let me go ahead and share my screen. Can you see that okay? That's very funny stuff. Okay, great. So we are here to benefit NumFOCUS, where open code equals better science. And we're going to hear a little bit more about NumFOCUS in just a moment. This telethon is sponsored by Don't Use This Code. Don't Use This Code is my employer. I'm a director there. And we really believe in giving back to the community. The thing about Don't Use This Code is that we are a training and education company specializing in Python services. So we do consulting, Python training, and events such as this, where we give back to the community. Oh, I'm being told I don't have a screen being shared. 1 second here. Let me just take a look at what happened here. Live TV, folks, live TV.
Lauren, this is the ghost from behind the scenes. Let's make sure we get all the mistakes out in the first just couple of seconds, just to make sure that the next 4 hours goes as smoothly as possible, because this is live TV, anything could happen. Oh my goodness.
That's true, that's true. All right, well, we didn't miss much in the slides anyway, because it's just a couple of logos. So here's the NumFOCUS logo. Here's the Don't Use This Code logo. And I also wanted to thank all of our early donors. So our early donors are listed here. If you donated more than $100, you get a shout out. So thank you, Vistuto, for your $100 donation. And also thank you to Smart One for $100 as well. Really, this is great. Our first stretch goal is $750. And so we are nearly halfway there. Really appreciate everyone who's donating. If you haven't donated yet, you have the next 4 hours to do so, and you might get a shout out as well. The link to donate is on our Tiltify. And so if you're watching this on Tiltify, the donate now is right there. If you're watching this on Eventbrite, then you need to scroll down to where it says donate now and donate there. And if you happen to be watching this on YouTube live, then the link is in the description of the channel. And I'm being told that we have 62 people watching live. So if you do a little bit of math, if everyone did $5 donation, we would probably reach our first stretch goal in a matter of minutes. Let me tell you a little bit about our fabulous prizes. So donors who give between $100 and $249 will receive a discount code to an upcoming Don't Use This Code seminar in matching amount to what you donate to NumFOCUS. So we are happy to credit your donation towards our next class. Additionally, donors at this level will be entered into a drawing where 3 winners will receive a grab bag of stickers. I know that you all really miss the stickers from our live in-person events. In the new normal, we're having to adapt. And so for the virtual events that don't have stickers, we're trying to make up for that. The first 5 donors who give between $250 and $499 will receive a grab bag of 15 project stickers, and also be entered into a 3-winner raffle. And everyone in this category will receive a discount code to the next PyData conference of their choice. And also the first 3 donors who give over $500 will receive a NumFOCUS t-shirt. And the remainder of these donors at this level will be entered into a 3-winner raffle. And everyone in this category will receive a discount code to an upcoming PyData conference of their choice, whether that is the PyData Global Series or the PyData in-person conferences when we return to in-person conferences. All donors who donate over $1,000, here we're starting to get ambitious, but I hope that you're feeling generous today, and maybe after you see James sweat a little bit, it'll help open your pocket, we will see. But donors who donate over $1,000 will receive a free ticket to the next PyData conference of their choosing, whether that's in person or virtual. And at the $5,000 level, don't use this code, we'll submit a pull request to have line art of your face entered into the standard matplotlib gallery. We have received word from the maintainers of matplotlib that there are no guarantees that this pull request will be merged. And donors who give over $10,000 or more will receive a free ticket to our next advanced case studies class in March that is being hosted by Don't Use This Code, as well as private tea time with James during the event. So this is definitely the woohoo level. If you feel like giving $10,000 or more today, you will definitely get a personal phone call from us. All right, I think that's it for my slides, other than just to let you know that we have a hashtag. It is CJamesSweat. And so please help us have this conversation either on the YouTube live comments. You can comment there live to be part of the conversation, or you can also reach us on Twitter using the CJamesSweat hashtag. We will be monitoring this. All of the best stuff will hopefully be forwarded to me, and you might even hear your name or comment read online. So with that, I would actually love to introduce to you, well, before we go to our special guest, I was going to say I'd love to introduce you to our special guest, but actually I want to introduce you to James first. So James, why don't you come off shadow?
Hey everybody, this is James Powell. I serve as chair of the NumFOCUS board of directors. I've also served as vice president for PyData since 2014, I believe, 2015. And I've been told that NumFOCUS is supporting open source scientific computing, but couldn't do it without you and without your donations and your support and your volunteerism. So Lauren and I have decided to volunteer ourselves this Saturday to help you on live TV convince yourselves that it's a worthy cause worth giving to. I'm not quite sure what I've signed up for. I think Lauren's going to tell me what it's all about in just a moment, but I wanted to thank Lauren for helping to put this all together, and thank NumFOCUS for all of the support that it's given all of us who use the open source scientific computing tools, whether in the PyData ecosystem or in the R or Julia ecosystem.
Thanks so much, James. And now I would love to introduce you all to our very first guest. We are honored here to be accompanied by Leah Silin, Executive Director of NumFOCUS.
Thanks, Lauren, and thanks, James, and thanks, Do Not Use This Code, for this very out-of-the-box idea for fundraising in a year that it is so much needed. So thank you for the whole team for your efforts and for putting this together. We appreciate each of you greatly. As they said, this is a fundraiser for NumFOCUS, and I'll give just a kind of brief overview of NumFOCUS. I want to specifically kind of focus on the impact that NumFOCUS is making through our work in the tools that you use and the tools that you depend on. NumFOCUS is here to support open source scientific computing tools, to make that research possible, to make sure those tools are on a healthy growth trajectory, to make sure they are sustainable, and that happens through support. We provide some vital services to contributors, and that's the area I'm going to focus first, our services to contributors. We also feel like it's greatly important to also support the user community. So we have programs that are also targeted to make sure the users of our tools are supported and have communication with the contributors, maintainers of the tools, in different educational initiatives. But back to our impact on tools themselves, as far as the contributors, working with the maintainers and project leads very closely to ensure what they have. And as a reminder, NumFOCUS has 40 plus sponsored projects, as well as approximately 40 affiliated projects that we serve. We are the legal entity and fiscal sponsor for our sponsored projects. And these are foundational tools in scientific research. They are used across many domains in science, research, pharma lately, in COVID research and analysis. And whether we are talking about our tools that are used in astrophysics or by astronomers for groundbreaking innovations. We have SumPy, just to name a few of the tools in that area, used for research for direct observations of the sun and heliosphere. AstroPy provides infrastructure to facilitate research on a global scale by professional astronomers. And a new tool, our new project TARDIS, is analyzing exploding stars. And many of our projects are also involved in astronomy in that aspect of scientific research. Our tools are also foundational in industry, data science, machine learning across all domains, as well as in education and widely used by governments around the world. So it's important that our tools are sustainable, are growing, and we support that internal project infrastructure. So the projects themselves provide their technical direction. We are supporting them on other sides. We work on their financial administration, on legal needs, which are great across our open source projects that we support. Many legal questions come into play, and we provide services in that respect. We also provide grant management, full grant management, which is huge. So we make it possible for projects to be able to have funding coming in. And how can we support those grants? Many of our projects, we have 40 plus tools, multiple grants on projects. So there's a lot of work involved providing that service. We also help projects with needed infrastructure, digital infrastructure that they need, making sure they have tools for meetings and for their user communities, as well as contributor communities, to be able to be supported. I'm trying to think if there's any other projects. We also just community networking. Projects that are part of NumFOCUS are part of a global network, and making those introductions and connections for project integrations and networking around the world. We also provide that as well for project community support. And then the other aspect that we really focus on for projects is promotion promotion. We want to help promote our projects. We want everyone to know about them. We want to increase the user base and make sure that we have a renewable contributor base as well, so that making sure the projects are promoted, and even working on projects with branding and those kind of services are also integral. So that's kind of where we are on the contributor side. On that community I guess direction, we provide educational services through our events. We've also are introducing NumFOCUS Academy, which will be an online learning platform, which is in its very, very early stages. That's supported by Sloan Foundation. We also are work with communities on DEI support. We have a lot of initiatives that we're working. Our Diversity and Scientific Computing Committee has worked to make sure scientific conferences have a guideline and resource book that they can use. And we're working on also putting resources together and more guidance for online events. Also, we have an event team that is able to work with our projects on events, as well as our event series PyData. So we support projects on both project events as well as NumFOCUS organized events. And I also wanted to mention we are just kicking off a project based on understanding contributor diversification and retention in open source scientific computing projects. We are grateful for the support by the Moore Foundation to be able to kick this project off. We have brought in a developer advocate and project manager for this, and we'll be doing in-depth research on our projects with the ultimate goal of providing guidelines that will be disseminated across open source projects for contributor diversification and retention. So we're super excited about that. So those are some of the things we do. As you support NumFOCUS, make donations through this incredible effort that Do Not Use This Code is launching, as well as donations through the website. These are the kinds of services that you're supporting for projects and for the greater community on a whole. We work really hard. We have a staff of 8. We could use a staff of 10, even 12. So, and during this year of 2020, a year that has we've faced great uncertainty budget-wise, the funds are especially crucial. So we thank you for your help and your ongoing support.
Wow, great. Thank you so much, Leah. NumFOCUS is even more involved than I even realized. It sounds very expensive. And it sounds like the kind of thing that, you know, if everyone could pitch in, we could get some really great work done. It's incredible what NumFOCUS is doing.
Thanks, Lauren.
So do you think James is ready for what he has ahead? 26 lightning talks in the next, you know, not even 4 hours now, 3 hours 40.
I have complete confidence in him. I know his coding will be, as well as increasing everyone's knowledge, and they're probably going to learn a lot. Also, James has a great way of being entertaining as he codes. So I think this will be, a great opportunity for people to, like I said, to learn something, see James kind of think on the spot, which he is also excellent at. So yeah, I'm looking forward to it.
Fantastic. Well, thank you so much again, Leah, for being here. And I think we better hop right into it, James.
I think the good news, Lauren, is that it'll be entertaining whether I succeed or fail. And so thank you for that fantastic overview of NumFOCUS, Leah. And I wanted to add 2 more things that you do at NumFOCUS to support the community. Number 1, I think we've forgotten about the stickers. Very, very important. How many stickers do we print every year? Probably thousands upon thousands. And number 2, even harder and more important is we have 40 projects. And they're each run by very talented, very principled, and very opinionated core developers. And as part of your work, you bring all of these people together, align them on a common set of principles, and convince them that we can do more if we build together than we could build if we worked alone. And that is not an easy job. It's a very hard job. You may think I'm difficult to work with, but imagine having to work with 40 core developers from 40 different projects. My goodness, I can't imagine how much work that must be.
They're great. They make my job, yeah, very, very rewarding. We have an incredible community.
So Lauren, we're ready to jump right into it?
I think so. Does everyone here know what a lightning talk is?
I think I know. It's a talk where you get electrocuted if you don't manage to get a good point out in a short period of time. Is that correct?
Correct. Okay. And so I've got my buzzer. No, it's not. We will not be electrocuting James today, but a lightning talk is a short 5-minute technical talk. Today, our theme is the alphabet. And James, do you know what you will be coding for each of the letters?
Well, I do know what the alphabet is. I believe there are at least 24, 25 letters in it. I'm not sure if there's more. I don't quite know what you want me to do for each letter. So why don't I write these down and you let me know what you want me to do?
Okay, great. So we'll do it in blocks. So we'll do, I guess, 5 letters, first 5 letters to start. So let's decide what you're going to do for A, B, C, D, and E. All right. So just off the top of my head.
If I remember correctly, A is for apple, B is for ball, and C is for, I think I didn't get that far in school.
Today we're doing this Python style. This is the Pythonic alphabet.
So, okay, there we go.
So A is for async await. A is for numpy.arange. A is for any or all.
Maybe I'll do numpy.array then.
Okay, I think that sounds good.
Okay.
B, what could B be for? Built-ins, breakpoint, bytes versus
breakpoint.
Yeah,
that's pretty cool.
Yeah.
Okay.
What about C? Collections, collections.counter, collections.chainmap, comprehension syntax is really important in Python. Collections.abc and instance check.
Could I do context managers?
You could do, all right. You could do context managers.
Okay.
It's classic.
And then
coroutines, there's so many good C words.
Yeah, there are. We might have to do just only the letter C for the next one of these. 26 around just that one letter.
I'm sure people would tune in for the 26 Cs. How about D? D is for, well, decorators, obviously. Descriptors, data classes.
I think data classes is pretty easy. I think that's a newer feature that people want to hear about.
Default dict. Right, data class. All right, great. E. E is for else. Elephants. Eval, exec.
Yeah, eval and exec. I think that works well. So I got my first 5. Do you want me to get started?
Yeah, it is 2:24 local time. I think let's go ahead and get started here.
And I got 5 minutes per.
5 minutes per talk. Don't go over.
Do the talks have to be interesting?
The talks do have to be interesting. That is a requirement.
Does the code have to work?
The code does have to work. I expect you to run it live on the screen.
Okay, well, let's see what I can do.
You see now why you might be sweating by the end of this?
Well, I'm in a climate controlled room here, so I've jacked the AC all the way up. So we'll see.
All right, fantastic. Before we do launch, I'm being told that we have a first trivia question, and the first person on Twitter to answer it by mentioning us at DUTC_training and using the CJamesSweat hashtag will get a shout out at our next break. First trivia question is, what inspired the coding language Python to be called Python? I think that one should be fairly easy, but go ahead and find your Twitter, open it up, be the first one to shout it out, and you will get a shout out on this live stream when we come back. I also did want to give you just a quick fundraising update that we are now halfway towards our goal. No, still almost halfway towards our goal. We've raised $350. So go ahead and click that donate button if you like what you see while James is coding.
And what happens when we hit 750?
Ooh, there's a big reveal for that. I don't have it quite in front of me, so it'll be a surprise reveal.
Fantastic. Wait, that's horrible. No, I don't like that at all.
I'm sure it'll be great for you. Take it away.
Okay, enough talk. Let's get coding. Let me share my screen with you, and I'll switch over to my view here. I think we're starting with the NumPy array is what we agreed on. And so I got 5 minutes to tell you something interesting about a NumPy array. Well, for those of you who aren't familiar with the library NumPy, NumPy provides you with a very interesting underlying type, which is the NumPy ND array. And if you look at a NumPy ND array, it may look like a collection like any other, like you used lists before. But one of the things that you may see with the NumPy ND array is it has certain characteristics that are not really possible to replicate in pure Python that make it particularly suitable for high-speed scientific or numeric computing. Let me show you an example of this. If we have a Python list with, say, the numbers 1, 2, 3, and another Python list with the numbers 4, 5, and 6, and we were to perform an operation on these two lists, for example, we were to add them together, the result of that operation that we would see would not be an element-wise computation. It would be some kind of structure-wise computation. Fundamentally, the Python list is an opaque collection of items. It doesn't really know what it contains. And so all the operations that you perform on a Python list are done structure-wise. This would be what you might call concatenation. And if you were to take this same list here and you were to perform another operation, like multiply it times a scalar value, you might think, oh, is this going to multiply all the elements by 3? Nope. This is still a structure-wise operation. It means repetition. So we'll see this just repeats the structure. It's just repeated addition after all. Whereas if you took a NumPy ND array and you'd perform the same operations on it, you'd see something slightly different. Let's take these two Python lists and we'll put them into NumPy's ND array type. I like to call NumPy's ND array type a restricted computation domain. And I think that's actually quite interesting here because what you can see is I'm actually starting with the Python list and Python integers, and I'm putting them into a structure. When I put them into a structure, the NumPy ND array actually unboxes your Python integers. One thing that you may already be aware of when it comes to a Python integer is that a Python integer supports automatic promotion, which means that there is really no maximum Python integer, right? You can keep exponentiating this as large as you have memory for, and it just keeps working. Whereas this NumPy ND array that I just created is actually machine typed. It is no longer a boxed integer. It's now some unboxed type. It actually is, in this particular case, an int64. And in addition to it being an unboxed type and a machine type, and importantly enough, contiguous in memory, operations performed on this ND array are mathematical operations. When I add two ND arrays together, it adds them element-wise. When I multiply an ND array, it does it element-wise as well. And so what you can see is this NumPy ND array is a very interesting type because it provides you with something that the core Python built-in types don't provide you with. It provides you with a structure that is aware of its contents, provides you with a structure which has control over its contents from the perspective of memory, as in these are all machine-typed contiguous values, and it provides you with something slightly different. Because if you think about a Python list, the Python list has a certain set of characteristics for it. The Python list has a fixed shape, but it has a dynamic size. Whereas a NumPy ND array has a dynamic shape and a fixed size. And I'll show you what I mean by that. If you take a look at a NumPy ND array and you look at the internals of a NumPy ND array, internally, what it really is a raw view of memory. And you can actually ask this NumPy ND array, what is the block of raw memory that you reference? And you can see this NumPy ND array with the values 1, 2, and 3 is actually that particular memory location on this machine. And if you ask the NumPy ND array, tell me a little bit about how you're interpreting that memory, you can see the NumPy ND array has the ability to, well, it tells you, oh, these are a bunch of N64s. And so what you could actually do with the NumPy ND array is you could perform something that you can't really do in Python. There's really only one similar notion of what I'm about to do in pure Python, which is swapping out the class on an object. But here I can do something quite interesting. I can take some values and I can cast them. What I can do is I can take a block of raw memory and I can tell NumPy, these aren't N64s, they're N8s. There's not 3 of them, there's actually 24 of them. What you can think is the NumPy ND array is this raw view of memory that gives you the ability to do mathematical types, that can control those types, that can perform no dynamic dispatch on aggregated operations on machine-typed unbox types that are contiguous in memory. And it has this interpretive layer on top of it, where that gives you the ability to say, what is the D type of this, and what is the shape and the strides of this. And so one of the cheap things you can do with the NumPy and D array is you can reshape it. So I can say this is a 2x2 structure if I start off with 4 elements in this. And this is a free operation. A list is always some linear structure of elements, but you can add elements. You can't add to the NumPy and D array. It's a raw view of memory, but you can tell it to be of any shape that you want it to be. And let's remove that line, and there we go. So I think that's A. I hope I did well. Let me move over to B. Boy, that took, I shouldn't have spent all that energy on A. Now I have no energy left. So let me go to B. I'll reset my timer and reset my screen, and we'll go to B. I shouldn't put that much energy into A. There we go. There's my B. Reset my timer, and let's go. Okay, B. B is for breakpoint. Now, you may or may not know this, but in Python 3.7, there was a new built-in added, which is the breakpoint built-in. Prior to Python 3.7, you had the ability to, within the standard library, debug some code using PDB. I actually prefer IPDB for these purposes because I like the IPython kernel a little bit better. But I'll give you an example. Let's say we have some code here, and this code has a bug in it. And if I execute this code, it'll show me that there's a division by 0 error. And one thing that historically we might do is we might say, accept some exception, and here from PDB import postmortem, and run a postmortem debugging on this. Now, this isn't going to work exactly with my auto runner, so I'll just run this script directly. And we got to spell Python correctly. There we go. And you can see, except exception. There we go. And I have a debugger, and I can go up and down, and I can take a look at the state of this thing. Well, in addition to being able to do postmortem debugging, what I might also want to be able to do is I might also want to be able to put specific breakpoints. So I could say from PDB import set trace, and I could set a trace on some particular line of code. And you can see with my auto runner, it's not going to work quite as well as I'd like it to, but you can see here I have to invoke F to make this work. There we go. And see, I have a breakpoint here, and I can see roughly where I am in the code. Well, in Python 3.7, they added a breakpoint instruction to do the same thing. And it has a corresponding bytecode. So if I look at the disassembly of H, I should see, let's continue. There we go. I should see, and let's move this above the invocation of this thing. I should see this thing. Oops. I should see this thing here. And you can see, it actually, sorry, there was no corresponding bytecode added for it, it's just a call function. And the reason that it's a call function is that you can actually swap out what the breakpoint is. And so you can go into the sys module, and you can set the breakpoint function to whatever you want it to be. I think it's like this, or it's breakpoint or breakpoint hook. So let's take a look at what it is. And it's called breakpoint hook. So I can set this to any breakpoint hook. And one cute thing I could do is I could probably write my own breakpoint hook that does not cause this thing to terminate, but instead gets the outer frames of the current frame and just iterates through them. So I could say for f in this, print dir f.frame, and I have to really remember, it's a good thing that I have, we'll call this breakpoint hook, and we have a breakpoint there, and we invoke it, very good. And this is sys that we do there. There we go. And that was our breakpoint. And I got to see what's in here, f.locals. There we go. So what I could do is instead of actually calling my PDB, which is what the default is for breakpoint hook, I could do the following. Every time I hit an exception, I could, and I'm going to skip the first and the last one. So we'll skip this just to make that work. And here I'll put this around and try except so I don't get that nasty error message. There we go. And what I could do if I really wanted to is, and I'll remove this here, I could set up a breakpoint hook that every time I hit this breakpoint hook just prints out the state of the current stack. And so here, if I were to pass some extra variables in here, you can see it'll print out all the local variables. Let's do y equals x times 2. We'll do y here. We'll pass y here. We'll do z equals y squared. We'll pass z in here. We'll pass z in here, and then we'll divide z by 0. Now here, this will still, we'll just return that because we don't care about the error. And there we go. And so what we should be able to do with this is trigger our code with the breakpoint. And let's make sure there's no bugs in this. So here we call G, oh, we have to pass in a value here. There we go. And you can see I can get the local state. And if I wanted to, because of Python's rich runtime, I could even get the frame f name. Is that what it is? No, I got to remember what's on this thing. We have the frame. I think it's the function name. So here we do f.function. And we could see what function we're in. And I think I can see the line number as well. So I could tell you where my code went. Line number. Yeah, there we go. So you can see what function I'm in, where my code went, and the local state. And so you can do some really neat things with breakpoint. You can set your own custom breakpoints. You can set your own particular logic there. Doesn't necessarily need to stop your code. And so what you could think of is this breakpoint gives you some arbitrary instrumentation point within your code. Okay, that's B. Now let's move on to C, which is our context managers. And I think I'm making pretty good time because I haven't run out of too much time yet. And so let's switch over to the context manager. Now, context managers are one of my favorite features in Python. And the reason why I like context managers is I think that it is a way in which you can convey to somebody who is semi-invested or semi-technical some mechanics of how the code works. And what I mean by semi-invested is there's oftentimes the case that when we work with somebody in an environment, they care about the results of our code, but they don't necessarily care about the process that we took to get there. But they still have some positive contribution that they can make as part of the code. They can tell us something like, oh, your approach is wrong, or, oh, you know, the business situation has changed very slightly. And one of the great things about Python is that Python tries to afford a particular readability. It tries to conform to a particular notion of readability so that somebody who is not as technical as you might be as a Python expert or not as invested in the particular mechanics of your solution can still follow along. And so I think the context manager does that quite well because you can think, let me do this with an example like this. Let's say some fake DB API, you know, I have some connect, and a canonical example of this might be something like this. I connect to a database, and here I might say, okay, with db.transaction, you know, and here I might get the transaction. And here I might do something like, you know, db.execute some particular SQL here and here. And I have two operations here, and I do something like this. And you could think that somebody who doesn't really know what a context manager is, or doesn't really, you know, have a very clear sense of how these context managers were implemented, could easily tell the difference between this and this. They'd say, oh, this one's not being done inside the transaction. Or they could tell the difference between this and this. They could say, oh, these are being done inside the transaction. And so we have a transaction within a transaction. And so what I really like about the context manager is the way that it can convey to somebody in a very simple sense what the code is trying to do. And they can give some feedback for you. They can say, oh, these two operations should be done atomically within the transaction. In a very similar sense, I'll show you a very simple context manager that we can write. And it's maybe something useful because we may want to use it later on. I write this context manager from scratch all the time. Now, I don't tend to write context managers directly using the enter and exit object model mechanism because I find it's a little bit too tedious. And I'm oftentimes coding with only 2.5 minutes of time left. And so I have to go as quickly as I possibly can. And so what I tend to do is I tend to use context-lib's context manager decorator in order to adapt a generator into a context manager, which makes total sense because if you think about it, a generator is a mechanism for sequencing operations. What it is a way to take some computation and add some structure into that computation. And a context manager is really just a metaphor for doing something before and something after, some strict sequencing of two operations, not an arbitrary number of operations. So really the two of these structures in Python really comport very well. They fit together very well. But let me write my context manager here. You may not know, but the time module has a performance counter that is a monotonic counter here. Let's do a finally. Let's do something like this. We'll do start equals perf counter. And this begins to show something very interesting. So if I have time, I'll show you something that I really like about this generator formulation. We'll say elapsed, and we'll see Greek letter capital delta t stop minus start 0.2f seconds. And here, Greek capital letter delta probably sorry, I don't know my Unicode names off the top of my head. We'll pull in sleep from the time module, and we'll just see if this thing works. So with timed sleep of 1, sleep of 1, here we go. Let's see if that worked. And we need to give this the message. So we probably need to put the message here, and let's just format that slightly nicer. There we go. So here we could do, this is some section, and you can see, you know, if you wrote some code like this, like somebody could look at this and say, these 3 things are all under this timer, but this one section of your code is only under this timer here. And we'll format this a little bit nicer. There we go. Now, there's one more thing that I want to share with you. I don't know if I can do this in the remaining 20 seconds I have, but if we were to write this as a class, the way that it would look is something like this. We'd have to write the enter, and we'd have to write the exit, and we'd have to store these things on the class body itself. And what you can see is we have an implicit sequencing here, obviously, because it's a context manager. But we also have some data flow and control flow, which step goes before which other one, and how the data moves between this. And it turns out that in this object model, that control flow is not very well, let's see, I think return self. Oh, no, this thing needs init. So we have to do self.message equals message. I think we're almost out of time, but what you can see is we're passing some information through the class in order to make this thing work. And it's not very clear how that information proceeds. We have the self.message, it comes into the class and it comes out of the class. It is often the case that a generator formulation, or more specifically a coroutine formulation, takes a implicitly sequenced sequence of operations that are in some kind of class API, and it linearizes them in the source text so you can see the control flow and the data flow. Hopefully we'll have a chance to look at this in a future Lightning talk. But unfortunately, I'm out of time on that one. So I think I got to go to data classes next. And I'm getting pretty good at switching over. So maybe I can take just one deep breath before I start I think I'm on 4 of 5. I'm almost completely out of energy. So hopefully we can just adjourn now. I think 4 hours of time has passed. So sorry, folks, telethon over. But let me take a deep breath and we'll go right into data classes. Data classes are something that were added fairly recently in Python. I think they were added in Python 3.7. And as you may have seen before, you know, it's just another shorthand for writing a class. One of the things that I find is I am often writing code with a focus on time to market. I just need to write some prototype, you know, as quickly as possible. And if I have any live coding skills, the reason I have live coding skill is the 2 types of things that I do for work are either corporate training, where you have to show something to somebody very quickly, or some kind of consulting. And if you're building a prototype, you want to show somebody what that prototype does in live code as quickly as you can. So you want to be able to sketch things out very quickly. And if that's your perspective, then what you want is you want some kind of helpers for being able to build reasonable structures as quickly as possible. And so the data class really, to me, fits into a trio of 3 common metaprogramming mechanisms for building classes really quickly. And the 3 are the data class, the enum from the enum module, and the name tuple from the collections module. And what's really interesting about these is all 3 of them use different mechanisms for metaprogramming. This is a class descriptor mechanism. So this is a class descriptor. Let's see if I can spell class directly. This is a meta-class-based mechanism, and this is a eval-based mechanism, or at least historically it was an eval-based mechanism. But my goal here is to show you a little bit more about this data class. It looks like my timer hasn't started yet, so I'm going to shut my timer down to about 180 seconds remaining, and I'll just guess that I spent a couple of minutes there already. So let's see. The way that you use data class is you push onto some class some behavior. And you can see this is a convenience mechanism because what it generates, I could write by hand. It really doesn't generate anything that I couldn't just write by hand, but there's quite a bit of boilerplate. One of the immediate things you can see is what we get out of this is a nice looking grepper. We also get out of this a automatic initializer. And this initializer might even have some default values. So there we go. Let's do this. And we get the ability to extend this very easily. So if we want to define what this thing is in relation to something else in terms of its equality, and we want to have some custom definition, we can extend this quite easily like this. Let's say a of 1 and 500, and these should be considered equal to each other. And so we get a lot of these conveniences. Now you might wonder, why did they use this mechanism? And why is it that if I take a look at the 3 of these helpers, they all look slightly different in terms of the mechanism that they use? Let's do B here, in order to metaprogram your way to a simple class. So let's say 1 equals auto, 2 here. So this is the enum, and the name tuple would look like this: C equals name tuple C with fields X and Y. Why do they all look the way they do? Well, one of the nice things about the data class is because it pushes behavior onto the class via the class decorator, it allows you to preserve your inheritance hierarchy. In other words, if it were the case that you had some inheritance hierarchy here, and that inheritance hierarchy were important to you for classifying what these items were, so you could say something like there's an A and there's a B, and you want to be able to say X is a B object, and you want to be able to assert that X is instance X of both A and B, then, that may be some fixed behavior you want. But if you also want this thing to be a data class, you want to have that convenience of not having to write all the boilerplate for the init and the repr and whatnot. You can just kind of push the behavior with the data classes data class. And the way we might typically write this is like this. I think this is a little bit misleading. These are what are called variable annotations. They were added fairly late in the game in Python, around Python 3.7 or 3.8. You might think, oh, this is going to allow me to constrain this type so it takes only 2 integers, but no, these are maybe MyPy related if you believe in the PEP484 type hinting. I'm still a little bit skeptical about the application of PEP484 type hinting for, functions which I write, which often take data frames as inputs and return data frames. And what you really care about is what the index is and things like the monotonicity of the index. Can't really capture that with PEP484 type hinting, at least not yet. But here's a simple example of a data class, and you can kind of see how it fits into a set of different approaches and different techniques for metaprogramming to allow you to do something which you could do anyway, but in a much smaller amount of time, very quickly, very rapidly, which if you're giving 26 lightning talks over 4 hours, is what you are obligated to do. Now, the last thing that I was asked to look at was eval and exec. And so I'll share with you a little bit about what those are. Let's switch over. Let me restart my timer, and we'll take a look at eval and exec. So you may be aware that eval is a way that you can take some code that's in a string and execute it and get the result. And you may be aware that exec is basically the same thing, but instead of taking an expression, you can take any sequence of statements. Now, one of the things that this shows us is, and this gives you a corresponding namespace, so I can pull that out of the namespace. No, I have to give it the namespace. That's right. These used to be keywords. These used to be statements in Python 2. So here, let's do namespace, and we'll use our walrus operator just so that we don't have to do that separately. There we go. So you can see I can, have any sequence, any suite of statements, and I can execute them, and I can pull this out. Well, when people look at that, they often kind of get a little bit scared because they say, oh my goodness, eval, this seems very dangerous. It seems very insecure. And one of the things that I think is important to understand when you think about exec and eval is that they really tie very closely to how Python itself works. If you think about how a module is imported, your import statement, or your import function here really just kind of does something like finds that module on, in file. So it does something as simple as, let's say we have a module from pathlib import path. We'll say, path mod with suffix .py. Your import more or less looks like this with open file name as f, eval, or actually exec f.read in some namespace. And then the namespace that this returns, or the namespace that's generated, this is just sys.modules of the module equals that namespace. So that's really all your import statement really does. And so if you think about it, eval is not really any more dangerous than importing some code. There are code signing mechanisms where eval will be significantly distinct from something like just importing a module, but these are fairly rarely seen in practice. And so for almost all of the deployed use cases of Python, evaling something is not really any distinct from importing a module. In fact, evaling something is not really distinct from doing something like this with open, mod.py as f, and then just doing f.write, some text, print hello. This is basically the same thing as eval. And you can think that the mechanism which ended up writing this code, maybe you have control over, maybe you don't. So import mod, here we go. And so these are just one of many different metaprogramming mechanisms. I gave a talk a while back about all these metaprogramming mechanisms. Perhaps in a future lightning talk, I can show you how they compare to each other and why you might choose one or the other, or even why it is that you might want to use metaprogramming at all. But as I said, historically, the collections.name tuple was an eval mechanism. In fact, in Python 2, if you happen to have Python 2.7 still somewhere, you can see that you can still see the remnants of it because your name tuple has an extra argument called verbose that allows you to see the code that it would eval. Okay, I think that was 5 lightning talks. I'm not sure. I've lost track of where I am and who I am. I think I just gave a couple of lightning talks. I can't quite remember what they were all about. Lauren, how did I do? That was a whirlwind, I'll tell you what. And that was much harder than I expected it to be.
Was it?
No, it wasn't as quite easy.
I don't know. Yeah, brush it off. I don't see you sweating there yet. Hi, Jane.
Hi.
So I would like to introduce everyone to my co-host for the afternoon. This is Jane Harriman. Jane, would you like to say a few words?
Sure. Yeah. Well, I'm excited to be here. I know, I guess, everybody on the call so far through NumFOCUS things, which I first got involved with through the Julia community. And these days, I work at Lawrence Livermore National Lab as an HPC technical consultant.
Fantastic. I'm so glad that you can join us. And you can help me with announcing our trivia and question person. who won the last trivia round? So the question was, why is Python called Python? And do you know the answer?
Guido is a snake guy. That's the answer. He's like one of those guys who's really big into snakes. You all know somebody like that in your life.
Yeah, I don't have a precise answer. I thought it had something to do with Monty Python, but yeah.
That's absolutely correct. The namesake is Monty Python's Flying Circus. And the person who responded on Twitter, our winner for this round, is Lit Seeker, LYT_Seeker. So congratulations, Lit. I also wanted to give us a quick donation update. So it looks like we are now at $630 raised out of our $750 first stretch goal. If we meet this $750 stretch goal, what do we get? James will submit a pull request to add a color map to Matplotlib with all of the names of donors during the telethon. So help us meet that goal. Again, we've heard from the maintainers of Matplotlib that there are no promises on whether something will actually be merged in.
And I think I saw in the chat mention of the next goal after that. Someone was asking about James's Vim configuration.
That's correct. People are always asking James about his Vim RC, aren't they, James?
Yes, and I hate telling them about it.
But you will reveal it if we raise at least $1,000 today.
I'm sorry, I switched over to my casual view so you can see what's going on behind the scenes. Ooh.
And I'm wondering, James, if you end up having to reveal your Vim settings, are you going to have to create new settings for yourself so you still have something that's a little, I don't know, edgier or proprietary?
Yes, my goal in life is to have the edgiest Vim RC among anybody. Um, no, I think the thing about the Vim RC is it's like it's nothing special. My Vim RC is very, very standard, and so I'm just like, why does anybody care that much? Jane, will you be doing any Julia live coding for us?
That is not at all my intention, no.
For the next one,
Live
right?
TV.
I know you're always supposed to say yes when you get asked things live, but I don't have your style, James.
I see that.
How much more time do I have in this break?
No, it's fine. I see that Tom Caswell actually commented that you don't want to reveal your Vim RC because it's actually Emacs. Is that true?
Let me tell you a story, and I'll see if I can make this on brand. I think the case between Vim and Emacs was, whenever you're in school, you learned one of them and you just use that for the rest of your life and you kind of got stuck. Some people switch over, but this is distinct from the tools which NumFOCUS supports. The tools in Python, the tools in Julia, the tools in R, which I think are tools which people actually come to by deliberate choice. They say the tools that I have, that I'm using, like some of these proprietary tools, I don't want to name any, are just insufficient to be able to do the work. They're not sufficiently open. I don't feel like my relationship with the vendor is a good relationship. And so unlike being locked into Vim or Emacs, as many of us are when you learn one of them in school, the tools in the PyData stack, the tools in the Julia stack, the tools in the R stack is something that somebody actually chooses to use. And this is why NumFOCUS is such an important organization, and supporting NumFOCUS is so important, because this is something that we have all identified really genuinely benefit our lives, benefit our work, maybe even benefit the world.
I agree. It's actually something really special. I could talk about this all day, but we actually need to hear from our next special guest. We've had a couple of, we've got a number of people lined up to hear from this afternoon. I think it's really exciting. Our very first one, we will hear from Stefan van der Waal, and he is a researcher at the Berkeley Institute for Data Science. He is also the founder of Scikit Image. Elaine, take it away.
Hello, everyone. It's such a pleasure to be with you today. And yeah, I'm very excited, primarily about watching James suffer in front of the camera. Oh, did I say that out loud? No, I'm very glad that we're here having this opportunity to talk about the tools we're building and about supporting those tools. When I was a young student in South Africa, I had the opportunity to work on NumPy for a summer. Someone managed to get hold of some funding, and that funding was spent in hiring a student to document the project. The idea was to document both NumPy and SciPy. An outrageously big task for one student over a summer, but hey, it excited me greatly. I took the opportunity with glee, and 15 years later, I'm still here working on those projects. I think what we saw back there is that, we brought the whole community together. We built infrastructure that allowed everyone to collaborate on documenting those projects. But a small amount of money was able to encourage people to participate in that project and to build the infrastructure necessary. And that is exactly what NumFOCUS's Small Developer Grants Program is for. It's to take small amounts of money allocated to projects for building infrastructure, documentation, doing refactoring, the kinds of things that can make a big difference in a project that has very few resources. Of course, NumFOCUS supports more broadly than that. We provide the infrastructure, legal and financial, to support projects in bringing in their own money and applying for grants and so forth, so that they can become sustainable ultimately. But also, we just try and keep the ecosystem healthy by making sure that attention is given where it is needed. So thank you so much for your interest in supporting these projects. They really need it. They benefit from it. And yeah, your help is truly appreciated. And we are so excited about building the next generation of these tools and making them available to everyone to use. So thanks very much.
And that's why I don't really use Python anymore for any of my work. I don't think Python's a very good, oh crap, we're on air again. Uh-oh.
Thanks so much for sharing those words, Stefan. Our very next guest that we would like to share a pre-recorded message of support from is Wolfgang Kerzendorf. And maybe Jane, you would like to say a few words about Wolfgang. You and him had a keynote earlier this year together, right?
Well, it was really his keynote, and James and I were interviewing him, but then it became more interactive as the fireside chat went on. And that was a really fun opportunity. We had some good conversations, and I got to learn a little bit about his interests and work and ways that he's, helping to support people entering into science and all of that. So I'm looking forward to hearing from him again now.
Fantastic. Let's take it away. Wolfgang,
What a
Wolfgang
year
is the creator
2020
of
has been.
TARDIS,
A
one of
very
the
tumultuous
newest
year.
sponsored
A
projects
year with a lot
of
of dark.
NumFOCUS. So that's a 2020
But there's some
sponsored
light.
project.
One of the things that 2020 has shown me is that as humans, we started off in small little groups, then started to make bigger groups like cities and countries. But now we're becoming an interconnected species. And this interconnection is done through technology. Technology bridges the gap, bridges the large geographical gaps. And one of the things that most people don't know is that this technology is often based on open source software. What is open source software? It is a new, very intriguing way of collaboration. One of the things that happens is people realize that we're missing certain software frameworks to encode video, to edit audio, and they come together through the internet, find people from all around the world, and build something. And the real miraculous thing is they do this for free. They do this for free because they want other people to use these frameworks and build new things and build better things for everyone to share. I think this is the true meaning of equity. And if we push on this, we can make sure that every idea is heard, making the life better for all of us. So what does NumFOCUS do? NumFOCUS helps support the maintenance and sustains open source projects that are based on science. That means people like me who make open source projects available to everyone in the world can do their work and not have to worry about supporting their teams. So why is this so important for research? So for me, I would like to know how stars explode. That is my research, and I'm the leader of the TARDIS community, which looks at how stars explode and what elements they spew out into the universe. Open source allowed me to connect with people in Australia and India, Russia, and many other countries, and bring them together and work together to make an analysis package that is not rivaled by anyone else, that is better than most other packages, specifically because I could get talent from software engineering to statistics to computer science to astrophysics and make something unique. And NumFOCUS has supported this effort. NumFOCUS supports many other efforts like these, specifically efforts that help all of us do research better, and for plotting and for statistics. Research not only for the interest of humanity to understand the stars, but interests like COVID-19 vaccines, interests like climate change, interests that face problems that will face humanity and will be a problem for all of us. So supporting NumFOCUS means supporting science. And as we all saw this year, science saves lives. The vaccines, the ambulances, the emergency rooms supported by science. Specifically, what NumFOCUS does is support this idea of open source, supporting packages that are freely available to anyone, freely available to anyone in the world that then can make their ideas a reality and then can help and make new cures, new methods that will aid all of us. So at this point, I would really like to thank NumFOCUS, and I hope you contribute to this effort. And this is Season's greetings from the TARDIS collaboration, and have a good end of year.
Hello, everyone. It's such a pleasure to be with you today.
Thanks so much, Wolfgang. So James, are you ready for your next batch of lightning talks?
No. Yes, maybe. I guess I've already signed up. I'm already 5 in. We just got to do it, right?
There's no way but forward.
There you go. So you want to give me what we're going to talk about, and we'll jump right into it?
Before we do that, I just wanted to give everyone a quick update on the donations. So we still haven't quite met that 750 goal yet. Reminder that if we do reach that 750 goal, that all of the names of anyone that donates today through this campaign will be put into a pull request. And that pull request will go towards Matplotlib to commemorate donors as a color map.
So you'll be immortalized for the rest of time in Matplotlib itself, which will be around until the end of time?
Potentially, yes. I don't know. Can they close the pull request without accepting it?
Probably.
So we shall see. But right now,
I'm curious here if people, well, for people who donate after the PR is submitted, do they get added, or do you have to be in before that pull request gets submitted?
Good question. We have another 3 hours left in this campaign. And I think, you know, when you miss your opportunity, you miss your opportunity, right?
They're high stakes.
It's very high stakes. So you're going to want to hit that donate now button. Make sure you get in on time. So far, we've raised $632.60, which is a fairly specific amount. And yeah, I think we can go right into it.
Okay, let's set it up then.
All right, so our next letter is F. All right, how about Func Tools?
Okay, Func Tools.
I guess
G?
functions generally. If you have any fancy ways of writing functions, James.
Okay.
Fancy functions for F.
Yes.
Let's stick with the Func Tools. For G, maybe get adder.
Okay.
H. Any ideas?
Something hash.
Okay.
Hash.
I could do hash.
Yeah, especially hashtag C James Sweat is used to talk about this as it's happening. What about I? Definitely iterators, right?
Iterables, iterators.
Yeah.
What is the difference again?
Oh, well, James, this is such an opportunity for you.
Okay. I'll look at it that way then.
And let's do one more. So let's do J.
Can I do a lightning talk on Jane?
No.
Okay. Has to be code related.
That's right. No proper nouns.
Okay.
Let's do JSON. I don't know
Okay.
if that counts as a proper noun, actually. I feel like a JSON is a name, but JSON.
If you're French, I suppose.
JSON.
There you go. Okay, let me share my screen and then go right back into the Thunderdome.
Sounds good. Before you do that, I think there was one more trivia question that we want to put out to the audience. So you're going to want to tweet at us at DUTC_training. Use the hashtag CJamesSweat. And the trivia question is, when was Pandas created? Is that the trivia question for the next one? I think so. When was Pandas created? Let us know.
Created or first released?
First released. Even better.
Because there may be like a Back to the Future style story behind Pandas that we'll have to get out of Wes at a later date.
My family and I just sat down to rewatch Back to the Future 2, and I would highly recommend it. It's a good snow day activity.
You know what's not a good snow day activity? What I'm about to do, which is 5 lightning talks in 25 minutes. So shall we proceed?
Let's do it and
Okay.
go.
Good
Let me
luck.
share my screen. Okay. And let me update my little subtitle, reset my timer. I'll try and fill some air. Oh, I need to set that back to 5 minutes. try and fill a little bit of dead air just so that I can remember what I'm talking about. Functools. Okay. Okay, so functools is actually not too difficult to talk about. So as you know, in the Python standard library, there are quite a few modules that you might interact with quite a bit, especially if you're doing something that you might call like functional programming. And one of them is functools. And in the functools module, I think probably the most common things that you might interact with are functools wraps or total ordering. And I would say that there's some other stuff in functools which I'm a little bit on the fence about. I think functools.partial, not actually that useful. I think you just use a lambda. But I think wraps is definitely something that's quite useful. One of the D words that Lauren came up with was decorator. Let me talk about functools.wrap in the context of a decorator. As we know, if we have some code, and I'll continue the timing metaphor that I used from before. So let's say I have some code and it's in a function, and that function is a slow function. And so let's import sleep from the time module, and let's simulate some slow function. And let's say that I want to time this function. And you can see that one of the unfortunate things about how I might time this code is if I were to surround it with like a start and a stop like I did before, and I didn't want to use that context manager mechanism because I didn't want to time a block of code. I wanted to time a specific function. I wanted to put the instrumentation into the function itself. Well, then I have this unfortunate result, which is that I have a very messy and very, very kind of unfortunately intrusive mechanism for timing. I have to put a line of code before and after. I've had a couple of these different calls. You can see I start to drown in the instrumentation code, and I can't really see what the underlying code was. And anytime you see this repetition of code that's starting to hide some mechanism, your first intuition might be, oh, why don't I write a function? And here I could do that. What I do is I'd write a function that takes a function as its arguments. And so here I take all of these common blocks of code, pull them out, and I'd write a function here that takes a function as its argument and evaluates it. And so I would transform these lines into lines that look like this. And that's still a little bit of intrusive because I still have to change what the lines do, but you can see at least that eliminated some of that noisiness from the instrumentation mechanism. But what I could realize is that in Python, functions actually are rich runtime objects. Maybe if I have time in a later lightning talk, I can show you how functions differ in Python from in a language like C, where they really are only something that exists to the human being at the compiler. But in Python, what I might say is because Python functions exist at runtime, and I can create Python functions at runtime, what I'll do is in this thing, I'll create a brand new function, and that brand new function will just forward whatever arguments are passed to it to the function that I originally closed over. I'll take that return value, I'll return this, and I'll return the inner function. And so if I had my original code with these three slow functions and I wanted to instrument them, what I could do is I could create a brand new function like this. And this thing just takes the original function, passes it through my mechanism here that creates a new function, and there you go. And so I could change each one of those lines like that, and suddenly I have my instrumentation. Of course, what I could also do is I could just rename the original function. I could rebind to that original function name. And when you see some code that looks like this is actually the decorator syntax. But what happens is when I do that, let's do this, I lose my help text. If you look at the help text here, the help text here is referring to the inner function that I wrote. And so one of the ways that I could get that help text back is I could realize that functions are live runtime objects. So I can do things like set, and they're also mutable. So I can do things like set their name or set their doc strings. And setting the signature is a little bit harder, but what I might then realize is every time I write a decorator, I'm doing these common lines. And so functools.wraps is a decorator that you use within decorators in order to preserve the help text and the signature of the functions that you are replacing via this decorator mechanism. The other thing that's in functools, which I don't know if I can do in 30 seconds, is total ordering. I told you that I really like mechanisms that eliminate the boilerplate for my code. What total ordering does, and this works really well with the enum type, is from collections. Let's do this from collections, from enum, import enum, from functools, import total ordering. What this does is it allows you to create a type that you assume has a total ordering associated with it. It allows you to create a type. And so let's say we have like a, I don't know, a card game, right? And here you have a 2. And maybe we'll do a simple card game with just a couple of cards in it. You can say these cards have a total ordering. That is, there's a transitivity to the ordering and some other properties. But I don't want to implement all the different ways to compare them. So what I can do is I can implement just equality and less than, and total ordering automatically provides for me all the other comparison operations for free. So it's another one of these boilerplate saving mechanisms. And it is one of these other ways to be able to jam through code as fast as you possibly can. Okay, that was functools. Let's go over to getAttr. Ooh, getAttr has got a lot going on with it. Let's see. Let me reset my timer and we'll go into getAttr. Okay. What we know is that there are a bunch of different protocols in Python. And one of the protocols that you have available to you is a protocol that looks like the following. You have some class or some object, and you want to retrieve something from that object. And you can write this in a couple of different ways. You can write it like this, or you can use the top level function, getAttr. And let me show you how this actually works. This protocol, I can probably sketch out a little bit of the protocol for you. Let's assume that this type initializes this variable x on its instance. So there you go. And let's say I want to build my own mocked version of getAttr. That's going to do the same thing. And I'm going to eliminate a couple of different considerations here, like slots, because I think slots is oftentimes something that people find very interesting, but I don't think it's that interesting. I think NumPy provides what a lot of people are trying to get out of slots, which is controllability of their memory. But let's see if I can mock out my own version of getAttr live. Well, here, what I'm going to do is I'm going to first look at the dict for the object. I'm going to look and see whether this attribute is in the instance state for this object was stored in a dictionary unless this object has slots. And if that's the case, I'll return this out of this dictionary. And so here you can see they match up. If the attribute that you're looking for is found on the class, then I have to do something else. Well, an obvious thing that I might do is I might say if this is in the type of the object's dictionary, then return that. Okay. But if this thing happens to have some base classes, and those base classes happen to have some attributes, then what you'll see is, okay, where do I go next? And when you do that, what you will find is that in Python, when they introduced new style classes, which is back in the Python 2 days, what they discovered was they wanted to be able to take the class hierarchy and linearize it. This is called C3 linearization. And so any class hierarchy in Python must have a consistent linear ordering associated with it, but diamond hierarchies are completely fine as long as you can create a consistent linear ordering. So I'll show you what that looks like. And I think in the time that I have remaining, I can't show you too many more details of this, but it also introduced what they call the method resolution order. All Python classes can tell you what the resolution order is. And so this is inconsistent. You can see it failed to create that. This is consistent. You can see D can tell you the order in which it'll look for things. So if you look for an attribute on D, it'll go down this MRO, D, then B, then C, then A. And so to continue this approach, instead of looking in the types dictionary, what I'm going to do is I'm going to look through each class in the objects types MRO, the runtime types MRO, and look there. So this is the next step for my getAttr. And so this will allow my getAttr to work with this Z. There you go. Now, the last piece of this is what we call the descriptor protocol. If the thing that you found in this class happens to be something with a very specific formulation to it, namely it's something with a get on it, and I don't really care what these arguments are, so let's just return 4,000. What you will see is that this getAttr protocol has a couple of additional hook points. There you go. You can see that's not correct. If the thing that you're going to return, if this thing's type has a get method, then instead of returning that thing itself, you return the get method. And this is the mechanism by which things like class method, static method, property, this is how these are invoked. So I don't know, this is self instance owner. So it would be, the instance would be the object and the owner would be the class. So here we go. Otherwise return RV. So let's see. And this should be get here. There we go. So there you go. That's a little bit of what getAttr does. There's a couple more mechanisms. There's obviously the getAttr with underscores before and after that you can overload. There's getAttribute. But here you can see the broad strokes of where you find something when you call it getAttr. When you do that dotted lookup, where it goes looking for things. First on the instance, then on the types. If you ever forget what the MRO is, I'll tell you, we all learned this in elementary school. You always row your boat gently up the type hierarchy. This is how you figure out which of your base classes happens to have the attribute that you're looking for. You go up the row. And if the thing that you found has a particular method named get, just by convention, instead of returning that thing, you return the result of calling that get method. This is how property, class method, instance methods, static method, this is how they all work. Okay, that was getAttr. Boy, these time flies when you're having fun, huh? Okay, next I'm supposed to look at hash. So let's restart our timer. And let's go. So hash. Hash is actually kind of interesting because one of the things that you might run into is, hash is a little bit misleading. A lot of the times, these underscore methods that you have on your objects are part of a public vocabulary that you're trying to provide for somebody. We may talk about this later. Hopefully we'll get to it, but it's often the case that you want to implement call or you want to implement len because you want to reduce the total surface area of your API. But hash is actually kind of interesting. Hash doesn't really mean what you think it might mean. It doesn't mean, oh, compute some hash that I can use somewhere else. It more specifically means compute a hash that I'm going to use strictly for the purposes of putting this thing into a collection type, namely a set or a dictionary. And hash has a couple of weird limitations in CPython. For example, you cannot have the hash value be a -1. It'll coerce it to a -2. And this is because deep in the CPython interpreter, this could be any other value and it'll return this value exactly. But if this happens to be a -1, it'll coerce it to a -2 because this -1 value happens to be used in the CPython interpreter as, an error value. And so what you can see is the implementation of hash will actually differ among the different Python implementations. This is a design constraint caused by CPython being written in C, but other Python interpreters that are not written in C do not have this design constraint. But I want to show you something else. Oftentimes it's the case when people talk about dictionaries that they say, oh, the keys of a dictionary have to be hashable, and that means they must be immutable. Here we can't use a list as a keys of a dictionary because it's a mutable type, and thus it is not hashable. And you might say, okay, this also applies to the set, which is why in Python we can't have sets of sets, because the set type is mutable, and the set being more or less a copy and paste of the code of the dictionary type, or at least historically that's how it was first introduced, minus any notion of the values, cannot have as its elements anything that isn't hashable, and thus anything that is mutable. And so this is why you have to have sets of frozen sets in Python, because this frozen set is just this mutable or immutable set. And by the way, this still won't work. Now, when people look at that, they say, oh, well, of course that makes sense because you can't really hash something that's mutable. But there's a caveat that they're missing. And the caveat is this. You can hash, you can compute the hash on a mutable object, but you must compute it on the identity of the immutable object, and you will only be able to put this object in a container that provides intermediated access. So I'll show you a real-world case for this. Oftentimes when you're working with the NetworkX library, you want to have some custom node type. So here what we're going to do is we're going to create a digraph, and it's going to have some custom node type. So we'll add a node, we'll add an edge with our custom node type. And for whatever reason, this digraph object is mutable. So why can't no, I'll do a class node. Why can't my node type be mutable? And what I'll want to do here is I want to compute a hash on this thing. And if this is a mutable object, what do I return that hash as? Well, if I return the hash as the contents of the thing, bearing in mind that the network X digraph is really just dictionaries of dictionaries of dictionaries, I risk losing this thing in the dictionary, because if I compute this on the state of this node type, then once the state of this node type changes, the hash will change, and I may not be able to find this anymore. And so the way that I'll do this is I'll compute this on the identity of this object. But this ends up working in practice because this network X digraph is not something which you have some disintermediate access to the contents of. You won't be able to say, oh, look up a new node with the same underlying state. Let's make these 1, 1, 1, and 2, 3, 4. This, by the way, won't work because these will be 3 independently different nodes because they'll have different IDs. So let's just do this, and I'll show you what you do. You wouldn't be able to do this. You'll see that it doesn't have that object, but that's actually okay for the network X digraph because most of your interaction with this thing is going to look like this. It's going to look like some intermediated access via some iteration over the contents of this structure. And so in practice, every time I've used network X and we've dealt with the network X graph as a mutable type, there's been some desire to make the nodes mutable. We have to hash them. The way you'd hash them is you hash them on the identity, and you make use of the network X digraph intermediating your access. And so what you would then do is you would probably then intermediate, or you'd probably then wrap your network X digraph like this, or we'll do it with a compositional mechanism here. And you would then probably provide, it's here, and we do net.g, and then you probably provide some mechanism by which to look something up. So here, we'll do self g, and what we'll do is we'll store on this structure, we'll intermediate the add edge, and we'll store on this structure some lookup. So we do self dot, by x equals some dictionary, and then we do something to add this next node like this. We do something like networks lookup 1. And that's how we would get this thing to work. So we'd basically make the type intermediate our access, and then we can compute the hash and identity. We don't run into the same problems that we do. This is why this won't work with the dictionary and the set type, because typically what you're looking for, at least in the dictionary type, is you're looking for disintermediate access. You're looking for that get adder straight into the type, and you're going to lose things because the IDs won't be the same if you construct an object with the same value, but it's a distinct object. So that's a little bit about hash. I think I'm next on to iterators. And I think I was asked to talk about the difference between iterators and iterables. And so, okay, you may have sometimes had, say, a list, and you ask that list, what is the next element? And that list tells you, I'm not an iterator. I can't tell you the next element. You look at that and you say, hold on a second. What do you mean you can't tell me the next element? Next element's 1. But if you think about this a little bit more deeply, what you might realize is it is not possible for this list iterator to tell you what the next element is 3 times in a row without remembering what the last element that it looked at was. And you'd have to think, okay, where is it going to remember what the last index that I looked at was? And if you were to store that information on the list object itself, then if you pass this list to two separate execution units, 2 threads or 2 async tasks, or whatever you pass it to, they would interfere with each other, because if they were both looping over this list, then it's going to be the case that they're going to affect each other's looping. And so that means that you must externalize the state for where you last left off. And so that's what an iterator is. An iterator is an externalization of the state of looping. And I think I have to spell these right, externalization of the state of looping. In other words, it is a reference to an iterable and some state, i.e. where you left off. And so what you do to get the next element of the list is you do xi as an iterator for this thing, and then you ask this structure what's the next element. And if we created 2 iterators and they were separate iterators, they both maintain that state separately, which means if they were in 2 different execution units, then everything would be completely fine because they would work separately from each other. But what you might realize is kind of interesting is if we have some computation, and that computation performs, does 3 things. Let's say we'll compute 10 times 2, we'll compute 10 squared, and we'll compute 10 plus 2. And actually, I'm going to do this off of something that's passed in, because otherwise it'll do constant folding on me. There we go. And then we return x, y, and z. What we have is we actually have 3 pieces of this code. We have 3 computations within this larger computation. And if it were the case that we were to put this not into an eager function, but a lazy generator, and we were to yield these partial outputs rather than return them all at once, and we were to ask this generator for a generator instance and go through that generator instance to get the next portion of the computation, and we have to give this an initial value, so let's give it an initial value like that, what we could see is this generator instance actually gives you access to its generator frame, which gives you access to its f last I, and the f last I, you can see 10, 24, 38, corresponds to the last instruction that this generator executed. In other words, I said 10 yield value, 24 yield value, 38 yield value. In other words, a generator is an iterable. You can iterate over it in order to trigger a computation. And a generator instance is an iterator. It's just the underlying computation, i.e. the reference to the iterable, which is a computation that one computation you broke it down into parts, and some state, i.e. where you left off, i.e. the last instruction that you computed. That's all an iterator is. It's really just the thing that you can iterate over. Now I have a couple of seconds left, and I'll show you something a little bit weird. There are some places for this iterator protocol, which I think are maybe insufficiently defined. What happens if I do this? Let me create an iterator on x's, and let me go through the next value. And I told you it's a reference to this object. What if I append another value to x's? What happens? What if I insert a value here? What happens? Let's insert a couple of zeros. It's a reference, and you can see this iterator is storing the index of the list that it's going through. And so if you mutate the list object while you have that iterator object active, that iterator object will notice that and will see that, because it's not anything but a reference to this underlying list. And so this can lead to some kind of strange behavior, because you might anticipate that once you create the iterator, you're going through the object itself. And this gets to some oddities when you're dealing with iteration over a mutable object, because what happens if, for example, I clear out the list here? That should cause the iterator to fail immediately. Yep, right at this point. So it'll cause the iterator to fail immediately at that point. And so some of these interactions between an iterator with a reference to a mutable object and then mutating the underlying object can result in some oddities in your code. Okay, so I think that was our I. What more do we have? JSON. Okay, let's restart our timer. Oops, let's fix our screen. We'll restart our timer. JSON. So we all have a sense of what JSON is. JSON is just some interchange format where we provide the contents of this format in something that looks like an object notation from JavaScript. So we have, JavaScript objects or maps, and we have string keys, and there's some restrictions to what, to how this must be formatted in comparison to what the restrictions on formatting are for JavaScript itself. For example, trailing commas aren't allowed, and that's pretty much all there is. Now, what I want to tell you about JSON is that I'm going to relate this to something that changed in Python 3.6. In JSON, the ordering of the nodes in this particular object or in this map are not part of the standard, which means that this JSON structure and another one here, this JSON structure and this JSON structure should be considered equivalent to each other, which is probably pretty easy for me to check if I use load s from the JSON module, because what will happen is these will be loaded into Python dictionaries, and irrespective of the version of Python that I'm using, these will compare as equal because they have the same value and the They have the same keys and the same corresponding values. However, if I were not using JSON but XML, where the order of the nodes is in fact part of the specification, or if I had some script that loaded JSON data and then made a transformation and then wrote it back to disk and I wanted a clean diff, it may be the case that if this dictionary type eliminated that ordering, then I might run into trouble. And it is absolutely the case that prior to Python 3.6, Python dictionaries were machine ordered. The ordering of that dictionary depended on wherever those keys were being hashed, the locations that they were put into. And you can see this behavior persist on the set type that is still a machine order type. In other words, if I iterate over the elements of a set in Python, I'll see them come out in an order that I cannot predict. It's not a random order. It is a machine ordering. The machine has decided how to order them, and it does not correspond to the lexical ordering that I specified when I write this. But I'm telling you it's not a random ordering, and you can see it's not a random ordering because if I iterate over it twice in a row, it's the same ordering. It's a deterministic ordering. It's just not one that I can predict. And this is always the case with dictionary. If you iterate over the dictionary keys, values, or items, they would always have a corresponding ordering. It's just that you couldn't predict what that ordering was. And to show you that you can't predict, if I were to insert a bunch of elements in the set, I were to mutate the set in between, then the ordering could potentially change. And so if I do this from string import ASCII lowercase, words equals from random import choice. Let's create a bunch of random words. So we'll create a bunch of random words of size 10. 10,000 should be enough. And if I say for W in words, s.add W, and I remove them, I should anticipate seeing the ordering change. This won't be the case with the modern dictionary. You can see the ordering did in fact change. And so unless you modify that structure for these machine order types, the ordering is consistent. It's just you can't predict it. Well, prior to Python 3.6, the dictionary type was one of these machine order types. So it would have that similar behavior to what we saw in the set, which is why in the collections module, they had an ordered dictionary type. And the ordered dictionary type in the collections module was a dictionary that remembered its insertion ordering. If I were to initialize a dictionary like this in a version of Python prior to 3.6, what I would see is that because I passed it a dictionary, the ordering was already lost. So what I had to do to make this work is I'd have to pass this tuples in a list so that I could ensure that what I passed in preserved the initial ordering. Now, in Python 3.6, the split table optimization was added to dictionaries, and as a consequence of the split table optimization, what we saw was that Python dictionaries now have insertion ordering. And so if we look at this code and we wonder, what is the difference in Python 3.6 and later? And bear in mind, Python 3.6, this was originally a side effect. In Python 3.7, this became part of the official standard. But still, because it became part of the standard in 3.7, I don't think you're going to be writing Python code for Python 3.6 and you're going to say, uh-oh, the dictionaries are ordered, but I can't really rely on that. You're probably still going to rely on it. The question may remain, what is the difference between the Python dictionary and the ordered dictionary? Because it seems like in both cases we have ordering. But, and this is critical and related to our JSON case, it is very much the case that with the Python 3.6 and later dictionary, the consideration for equality is based only on contents. Whereas for the ordered dictionary, the consideration on equality is based on contents and ordering. Thus, not if you were using JSON, but if you were using something that had order dependency, or for whatever reason, you were using some JSON derivative that happened to have some kind of ordering dependency, you may still want to use that ordered dictionary type because you may still want to say, are these two documents equivalent in terms of not only what they contain, but their underlying ordering? That's JSON for you. And so let me go back to my list. It looks like, oh, time flies when you're doing lightning talks. It looks like I'm all the way through those 5 lightning talks. Didn't even break a sweat. I think we're going to have to up the difficulty. I will unshare my screen and let's see what Lauren has for us in store. But folks, donate to NumFOCUS. It's a good cause.
Wow, great, James. That was a whirlwind. How are you feeling?
I am about to reach for my performance-enhancing drugs to see if I can make it through the remaining ones. So I think I'm going to go get myself some Coke.
Okay, kids, don't do drugs. I did
Coca-Cola.
What's that? Including Coca-Cola. I did want to give a quick fundraiser announcement. So we have reached, we've raised $814.80. So we have reached our first stretch goal of $750. Yay! So that means that all of the donors today, including those who come after, anytime before the end of this telethon, anyone who donates today will be included their name in a PR request to a color map on Matplotlib. No guarantees that it will be merged, but it will be on a pull request. So you're definitely.
And I think the colors will be the NumFOCUS colors, the teal and the orange, which will give it a higher percent likelihood of actually being accepted. Oh, and here's my Coke. Don't worry. It's a big one. It's a big one.
Wonderful, wonderful. I love it. Okay, and then also very quickly, what year was Panda software first released? That was our trivia question for this round. The answer is it was released in 2008, specifically on January 11th, 2008. And our winner from Twitter is Dipangsu Goswami. So I apologize if I got your name wrong. Tweet at me if I got your name wrong. Apparently, I got the first winner's name wrong. It wasn't Lit Seeker, it's Light Seeker. So I would like to make that adjustment now. And now, I guess without further ado, Jane, would you like to introduce our next very special guest for this segment?
Sure. In this segment, we have two of NumFOCUS's founders, Fernando Perez and Travis Oliphant. Fernando Perez is the Jupyter BDFL, and Travis is the creator of both NumPy and SciPy. And so, Fernando, would you like to say a few words?
Yes. First of all, thank you, Jane and Lauren and James, for all the work that you've been doing today. It's absolutely wonderful. And for those who have donated and participated, we really appreciate it. I wanted to kind of reflect a little bit on NumFOCUS, and this is at this point it has become what's already kind of a long history and a really impactful history. We co-founded NumFOCUS, Travis and myself, together with Perry Greenfield, Jared Millman, and John Hunter, creator of Matplotlib, who sadly isn't with us anymore. He was a dear friend to many of us back in 2012. And I think now, as I reflect on the impact NumFOCUS has had and sort of the space it fills, I'm really glad we did this, because when I started doing open source work, it was about code, right? It was IPython. I met Travis, I met Eric Jones, I met John Hunter, and we were completely focused on the code. But gradually, we came really to understand and appreciate that the code is only one small part of the story. And that as these projects grow, as our idea that we could build an open source stack to do science, to do research, to do education, to do what we now call data science, we didn't use the term at the time, other aspects beyond the code will be the ones that really dictate success or not, that will really dictate societal impact or not. It will be about, first of all, the stories that people will be able to tell with our code. Many of our users may not necessarily contribute directly to the software, but they use it for their purposes, for their research, for what they teach, for the problems they're trying to understand. And then we will have to build an ecosystem of interoperable tools. Our projects work together, and they rest on a human community. And NumFOCUS nurtures all of that, right? NumFOCUS is precisely the scaffolding and the architecture, the human architecture that makes all of that possible. And that has, first of all, been led by amazing people. I think a shout out to not only James, but Leah and Andy, who have sort of shepherded the organization for years, is absolutely warranted. And they have really pushed the understanding that this human community that requires mentorship, that requires management, that sometimes faces difficult challenges, and we've seen some of those challenges over the years, is actually critical to the success of what we think of as technical tools, and for those tools to really have the kind of life-changing impact that they're having today. Backstage, I was chatting for a minute with Travis. He was asking, how are you doing? And I said, well, I'm a little tired right now and stressed out because I just wrapped up a semester where I taught a course called Data 100, which is called Principles and Techniques of Data Science. It's the upper division course that is mandatory for the Berkeley data science major, but is also extremely popular campus-wide, even for non-majors. I just finished with my co-instructor and an amazing team of TAs teaching 1,200 students. So this is a course where we teach every semester about 1,200 or so students. In the summer, another few hundred. We're basically covering roughly half of the campus, the Berkeley undergraduate population over time goes through this course, which means that at Berkeley, if you talk to a random undergraduate, you have probably better than a 50-50 chance of finding someone who considers it completely normal to load their data into a Jupyter notebook, import it into pandas, visualize it with matplotlib, model it with pandas, stats model, scikit-learn, and they consider that to be their normal work routine. And we have heard from faculty how life-changing this is, because now they hire undergrads for their labs, and the undergraduates actually come in with really sophisticated chops in data analysis and using the industry tools. And some of these students actually have contributed to the open source ecosystem. This was in many ways, I think, the dream that we had when we were talking 20 years ago about these ideas. This was sort of the dream that we could make this possible. And NumFOCUS in many ways is actually the human infrastructure that powers this. So I can only thank everyone who contributes to the projects, who makes NumFOCUS possible, and those who are helping the organization today. Please donate. You are truly making the world a better place with these tools. And so thank you. Thanks for having me today. And I look forward to seeing more of James doing his the kind of crazy things that he does with the Python language. Thank you, folks.
Thank you, Fernando. And now, Travis, are you ready to share with us?
Sure, happy to talk. I mean, I love NumFOCUS. It's such an important organization. Really grateful that Fernando did a great job explaining some of the impact it's had. Early on, I sort of give a little story about how we started NumFOCUS. It was, I've been since I left academia, I did a lot of coding in academia. I still love to code. I don't get a chance to do it that often, but I still really like just the doing of the code. But you start to recognize that there's a real need to connect. How do you connect actually the incentive structure and the companies out there? There's a lot of money being made using these tools, but it's not coming back and it's not being brought in to support the actual creators of the tools and the maintainers of the tools. That's been a long-standing problem and one I've been really intimately interested in. And I started as a scientist. I still, at my heart, I love to geek out over science and love to read the latest papers, and I'd write more papers if I had time. But for the past 13 years, since I left academia, I've been basically wrapped up in entrepreneurship, trying to figure out how to start businesses, trying to figure out how to get people, how to employ people, how does that whole process work. As I was starting to do that, I recognized that we need a organization that is a legal organization that's motivated and for the community. Every organization has a culture and has a concept, and it's governed by its board of directors. It's governed by who owns it. And we needed a community-owned organization that would represent the community. As NumPy started to grow, who should own the copyright of NumPy? Who should own the copyright of SciPy? Where should the IP? Who do you talk to if you want to ask about IP issues? Those are real questions that around 2011 we were asking. Like, that's a good question. There was a person who had grabbed the copy, they have the domain of numpy.org, and they were just holding it, kind of going, well, I don't know who to give this to. Do I give this to a company? Do I give this to a legal organization? So it really kind of, well, I guess we need to start an organization. So it's work to do that. Like, there's paperwork to file, there's people to do a lot of work. I was so grateful we found people who would spend the time doing that. That was a big deal. Early days. And I reflect on, the early conversations, and it was very early, and we didn't know exactly what we were doing, but we would meet regularly and we'd talk about how to get it started, and it was a lot of fun. And then, of course, the key to success is getting people engaged and on board. Like, and I've seen this over and over again with projects and with communities and with everything. You have to have an energy to get it started, but further, you have to have an energy to involve more people, so that you could just incorporate more and more activities. So it's really been exciting to watch over the past 10 years, 8 years, I guess, how it's really grown, how NumFOCUS has gone from this kind of idea that we've had, into a bigger deal, that is supporting a lot of people. And that's just exciting. It's been people like watching James, for example, go to every single PyData conference that exists, trying to figure out how do we actually pay administrators, right? These are things that have been a real part. So I just am really grateful. I'll echo Fernando's statements. Thank you for being here to do this. If you're out there wondering if you should donate, donate. This is good. There's good work going on. A little bit helps. Every little bit helps. If you can donate in big ways, small ways. If your company that you're involved with can make a donation, this is critical work because it's the infrastructure work that lets all this happen. So I'm happy to support it. We support it however we can. I'm constantly looking for ways to continue to support NumFOCUS. So thanks for having me, and I appreciate being a part of it.
Thank you so much, Travis and Fernando. Really appreciate it. I have one very important question for the both of you. ¿Por qué es tan importante la comunidad internacional de PyData? ¿Ah?
Es tan importante. De acuerdo.
Fernando, you're on mute.
Yo soy colombiano y las ideas que me llevaron a hacer trabajo en lo que llamamos open source fueron precisamente en parte motivadas por querer poder compartir el trabajo que estaba haciendo acá en Estados Unidos con mis colegas, con mis mentores, con mis profesores de Colombia, sin ninguna barrera económica. Y eso es algo que he visto cómo ha cambiado. Este año tuve la oportunidad de dar una charla en PyCon de Colombia. Travis estuvo en Colombia en octubre, el año anterior en SciPy de Latinoamericana, y hemos visto cómo esas comunidades están creciendo. Yo eso es algo en lo que espero en los próximos años trabajar muchísimo más, conectarme con la comunidad colombiana. El equipo de Spider, por ejemplo, es en gran parte colombiano y hacen un trabajo extraordinario. Han estado haciendo las traducciones, Gonzalo ha estado liderando las traducciones de Jupyter Lab al español, y yo creo que ahí esa es una de las próximas fronteras, es no solamente diversificar nuestra comunidad aquí, lo cual es importante también en términos de género, en términos raciales, sino también diversificar en términos culturales y geográficos, que no sea solamente un asunto de Estados Unidos, de Europa, de los países del norte, sino un asunto realmente global. Y en ese sentido me encanta que eso sea algo que NumFOCUS también prioriza.
I completely agree. This is truly an international community.
Absolutely. It absolutely is.
James, it looked like you had a quick question.
I was just impressed hearing Fernando and Travis both speak about their international experiences, trying to build not just the community within the United States, which is historically been, the source of a lot of computing innovation, but making sure that this access to opportunity and access to resources, access to open source software is available worldwide. And so I'm a very, very big supporter, not only of NumFOCUS because of its work in contributing to the projects, but also how it builds communities throughout the world. I will note that this year we did our very first PyData event in East Asia with PyData Taipei. And you can see there are PyData events coming to every corner of the globe.
Great to see.
I also wanted to hear Travis here speak a little Spanish, so I was waiting for that to come in too.
Un poquito de español. Se me olvida mucho, pero vivía en las Islas Canarias de España por 2 años. Entonces hablaba mucho. Me encanta el idioma todavía.
No, y todavía lo hablas muy bien. Excelente.
That's awesome. Well, thank you so much, both of you, for sharing your experiences, with NumFOCUS today and yesterday and to the future. It's really always nice to hear from those who were there at the beginning and to see that, NumFOCUS is going strong. Speaking of going strong, our fundraiser is going strong. I just wanted to give a quick update on the amount raised, that we have reached our $1,000 goal. We're now at 1,075. It just switched right in front of me. So that does mean that James will be doing a Vim reveal at some time during the telethon, and that our next goal is $1,750. So $1,750. That's our next goal. Thank you so much, Fernando and Travis.
Before we let Fernando and Travis go, can we ask them to help us make a plea to hit that 1750 mark? Travis and Fernando, in whatever language you choose. Can you help us encourage the people who are watching at home to donate so that we can raise $1,750 for NumFOCUS, for the projects, for not only our communities here in the US, but the international communities that are behind us in open source scientific computing?
Yeah, please, please. This makes such a huge difference. Open source can level the playing field and help so many people internationally. NumFOCUS offers grants. They offer development support, mentoring support, and diversity and inclusion improvements across our field. There's so much work they're doing that's really critical that nobody else will do or can do. So please, please, NumFOCUS is a great place to put your end of year donations. In the United States, it's tax deductible, so there's no reason not to.
Absolutely. And many of you in industry benefit from these tools. Please give a little bit back if you can. They are free for everyone. They are free to the world. They are free to those who can less afford them. But if you can help support them, they are not free to create. People need to put in their time and effort. And we try to do many things to find those resources, but we also need your help. Por favor, ayúdenos. Ayúdenos desde cualquier lugar del mundo. Nos pueden ayudar. Estas herramientas les sirven a todos. Elles aident les chercheurs de tout le monde, partout dans l'univers. Alors, on a vraiment, vraiment besoin de votre aide. N'importe quel petit que vous pouviez contribuer nous aide. En ce moment, on essaie d'arriver à $1,750. S'il vous plaît, contribuez. Merci beaucoup.
Wow, thank you so much. Take care, guys. Thanks for stopping by.
Hasta luego.
Hasta luego. Okay, James, I think we better get right back into it. And I have prepared, did I prepare? I have prepared your next set of letters. Are you ready, James?
No, maybe. Let me switch over and let's see what we have.
All right. That was good, huh, Jane? Do you speak any foreign languages?
A little. My French is better than my Spanish, but both are not great right now. I'm a bit out of practice, but I'm trying to read Harry Potter in French right now as a review. So
there you go. That's a great way to practice.
Yeah.
Okay, James.
Well, I'll save you. I'm ready to go with the coding. So
yeah, exactly.
I have to put Jane on the spot.
We'll save French Harry Potter for maybe one of the next stretch goals. Speaking of stretch goals, if we do reach our 1750 mark, what do we get? After reaching this, don't use this code. We'll bring back the standalone pub quiz series. So if you love pub quiz at PyData and you wish that you could attend pub quiz more often to challenge yourself in terms of your technical prowess and abilities, yeah, you're definitely going to want to join that standalone pub quiz, but we can only release it if we meet our stretch goal of 1750.
So hold on a second. If we hit that stretch goal of 1750, we'll start doing more pub quizzes. And let me remind us that the pub quiz is where I have the answers ahead of time. So it's really easy for me. Can we just do that instead of this instead?
Nope.
Oh.
Already signed up for this. Sorry.
No way but forward. All right. Okay. Are you ready for K through O?
Lay it on me.
All right. So K has got to be quarks, star keyword args, right?
Okay.
L for Len.
Okay, for Len, okay.
M for meta class.
Okay.
N for Nan.
Like the not a number, or like, you know, your Nan who gives you nice gifts at Christmas.
Yeah, or the non that you eat your food with.
That's another one.
Yeah, no, not a number.
Okay.
Any type of not a number. NumPy not a number, any of them.
Okay.
And O, let's talk about big O notation.
Okay.
Yeah. You ready for it?
Okay. Yes, let's go right back into it.
Let's go right back into it. When are we going to do your Vim reveal? Is that going to be right after this segment, right?
We can do that right now if you'd like, whatever you prefer.
No, I think people are eager to see more sweating, more lightning talks.
Okay, let's do it. I'll share my screen and then let's see if I can do 5 lightning talks on keyword arguments, the len method, meta classes, nan, which is the same as numpy.nan, or the float nan is the same as numpy.nan, and big O notation.
Yep, perfect.
Okay. I'm ready whenever you are. So I'll restart my timer and we'll go right into keyword arguments. And so let me think of something that's interesting to talk about for keyword arguments. Well, as you already know, you have a Python function, and that function could take star args or star quargs. This is additional variadic positional arguments or keyword arguments. In other words, this function can be passed any particular argument spec. And one of the things that always kind of irritated me when people would write memoizing decorators is that when they would write a memoizing decorator, like they'd write some decorator that looks like, from functools, import LRU cache, and they do something like LRU cache, and this is some slow function, from time import sleep, and we'll make this a really slow function that adds two numbers together like this, and we'll sleep for 1 second. And then here, what we should see is subsequent calls to this thing should, if we can get this working, here we go, subsequent calls to this thing should speed up. And so you can see the first few calls, the first time we call what's particular arguments, it's slow, and then it gets faster. Well, one of the things that always irritated me here was that they never normalized for different ways in which the argument spec could be passed. And so what we'll see here is that those two latter ones should be fast because look, it's the same arguments, I'm just passing them slightly differently. And so what I thought would be a much better way to write a decorator might be, a memoizing decorator, might be to do it something like this. We know that a decorator isn't necessarily a function that takes a function and returns a function so much as any callable that wraps a class or a def-defined function or generator and returns something. And so my favorite implementation of the decorator looks something like this. What we'll do is we'll memoize some particular function. We'll store the function somewhere. When you call this thing, this is the same thing as doing the get, we'll do a get item. Actually, no, we have to pack this up. So when you call this thing with some args and some keyword arguments, we'll actually turn this into a call that looks like this. And we'll pack the arguments in this way. We'll say the key is a tuple. Actually, the args are already a tuple. And here we'll turn this into a frozen set on the KW args items. And we can do some additional wrapping to avoid some of the issues that we run into with mutability, with hashability of these things. But I think this is an easy start. And then what we'll do is we will say, if we do not find this key here, if this is missing, then we'll unpack this thing right back out. So here we get the args and the keyword arguments. We'll unpack that straight from the key, and then we'll actually invoke the function in order with these things. So here we go. And what we can do is we can put that into a dictionary here. So that should do what we want. And we'll return this. This is a return value. And then we'll set this on ourselves. So we'll say set key equals RV and we'll return RV. And so this thing should give us a way to memoize our function. And I kind of like the dictionary formulation because it really ties us very closely to this notion of the dictionary being one way to perform a lookup table on some function with a bounded domain. Now let's see, this should be memoize, and we think we have to return the memoize object here. This thing is a subclass of a dictionary. There we go. And we have to pull sleep from the time module. There we go. And the one thing that this also doesn't support is this keyword arguments problem. But what we could do is we could make use of inspect, of rather signature from inspect. And then right here, what we could do is we could normalize these. So we could get the signature from self.f. We could bind it with these arguments. And then this gives us the args, or this gives us the parameters. Let me print this out for a second, just to see what that looks like. Yep, and this gives us params.args, and I think params.kwargs. And this should give us a normalization. Got to do a dir here. This should allow us to normalize those keyword arguments. So it's, yep, args and quargs. And what you can see is this args and quargs nomenclature is actually in the standard library itself. This thing, and this should be what? Params.args, params.kwargs. And what we should see here is and we should do this on the lookup actually. So we should do this here. And then we'll do this. We'll construct the key. Yeah, we'll construct the key off of this. So we'll do this equals params dot. So this will give us some normalization. We'll do it on the call. And then down here, I think that gives us what we want. Params.args and params.kwargs. And then down here, we should just unpack it like that. So they should already be normalized at this point. So hopefully that works. And we got to get this thing working or we're going to run into trouble. This needs to be forced into a dictionary. There we go. Yeah, there we go. Told you I could do it. So here you can see kwarg normalizing memoization written in the form of a decorator that is actually a class that returns an instance. Ooh, I knew I could do that. I'm feeling good. False confidence, because this is about to crash and burn. Our next thing that we're going to talk about, and let me update my screen before we get to that, is len. Okay, what can I tell you about len? Well, one of the things that we might know is that oftentimes when we're writing a Python class, it is our desire to make use of a built-in vocabulary that's provided us to the Python language, as opposed to inventing that vocabulary ourselves. So if we had some problem that, say, modeled a card game, and we had a deck of cards, we don't really want to have some code. Here's a deck of cards, and then you say, d.num cards. You don't really want to write something like this, because this is just going to lead your user to say, is it num cards? Is it number of cards? What on earth is this? And you'd rather just say, len of d. This is how you can convey that this structure, which is a deck of some kind of cards, has some notion of its size. But whenever you do that, you have to be very careful to pay close attention to what this protocol actually means. So we'll create this with, say, a 4 of hearts and a 3 of clubs, and you can see, okay, our deck has 2 cards in it. Now, as I said, you have to be very careful about what that means, what this particular protocol means. Like in the case of hash, if you don't look at it right, if you think, oh, this represents just some numeric value that's computed from the state of the object, that's not quite correct, because hash is much, much narrower in terms of how it's used. But len is actually a little bit broader, and len is something that, anything that has a notion of a size, or anything that specifically is a collection .abc .sized, you'd implement len on. And let's just double check. I think this should be sized, because I think all it requires is the len is instance d sized, but it may also need an iter. Oh, no, it's all it needs is a len. Okay. Well, the thing with len is, if you have to pay attention to 1 or 2 little caveats, because you could think that if I were dealing with, say, a card game example, what I might also have is like a hand of poker, flush, straight, or whatnot. And you might say, oh, for this particular hand, I want to look up the probability, but the probability is just a measure in some measure space. And so you might say, oh, you know what? I could just write a len, and I'm going to be really clever, and I'm going to return, the probability. It's 50% probability of this. But what you're going to find is that len is actually a little bit more limited than that. It has to return an integer. And you might say, you know what? I'm going to model in this game like a pot, and this is the amount of money, or maybe I'll model my purse. This is the amount of money that I have, and this len, is an integer. But, when I play poker, I play for 20s, not for 1. So it's always some integer value. And so, but I'm not very good at poker. So, I have a negative amount of money. And when I compute the len here, you can see that's also a problem, because the len has to be not only an integer, but greater than 0. And so when you think about these different protocols, and you think about the design that you're trying to create, you really have to think a little bit about what these protocols mean in terms of the conventions and in terms of their restrictions. In the case of len, what we see is this represents some discrete non-zero measure of the object. But there's something beyond that. If you think about some objects, they may have multiple distinct notions of their length. Like, for example, a panda's data frame is a 2-dimensional structure. Is its length the number of rows or the total number of cells? And that could be ambiguous. And maybe at a later lightning talk, if we have a little bit of time, we can talk about what actually happens when you have this ambiguity. Because it turns out that when you're modeling a Python object with these object model methods, or these data model methods, what you're looking to implement is the one unique privileged notion of that thing. And so if you had a class and you showed it to me and you said, I implemented len on this class, the first question I would have for you is this the size of this thing as a measure that is non-negative, discrete, i.e. an integer, and is this the one unique privileged notion of what the size of this thing is? Because it has 2 different notions of size. Maybe you don't want to implement this as a len. Now, I want to show you one more thing about len. You can, well, I'll leave it there. I might have showed you that, in the built-ins, you can always do something like this. This is just too obvious, right? Here, I'll say len. This used to shock people, but now I don't think it shocks anybody. So here you can always swap out what len does. And surprisingly enough, it doesn't cause as many problems as you might think. Right? That doesn't cause as many problems as you might think. Hopefully, too bad we already went through B, because I could have showed you all the weird things you could do with built-in patching. But here you go. You can, len is just one of the protocols like any other. It has the same considerations as all the other protocols, and you should be careful when you implement it to really understand what it means. And if somebody happened to implement len in a way you didn't like, just go into the built-ins and patch it out, and you're good to go. So I think that takes care of len. The next item that we wanted to discuss was the meta class. And I don't know if I can do meta classes in 5 minutes, but I'll give it a try. So as we know from Python, when the new style objects were added to Python, a new hierarchy was created. So they all descended from object, and they all had a meta class. And so in Python 2, it turns out that there are a couple of different ways you can create a new style object. A new style object was either an object that directly inherited from object, whoops, or an object that inherited from something that inherited from object, or a object that had a meta class. And you used to be able to do this. You used to be able to put it inline. And a meta class was just a class that derived from type. Now, what the thing actually meant was sometimes unclear to people. And so you'd get a lot of advice saying, oh, stay away from meta classes. They're really dangerous. They're really unpleasant. They have no purpose. They're just about job security. They're just about making the lives of your coworkers harder. But I really push back on this and reject this, because when I look at meta classes in Python, I see a specific pattern that they are there to solve. It's not a pattern that everybody has, but it is a clear, unambiguous pattern. And there are only 3 ways that I can think of easily to go about solving this problem. And the problem is, if you have a base type and a derived type, it is possible to create constraints on the base from the derived. So for example, if you had a function here, and here you had a function that required that the base type look a certain way, so you can return self.foo, and you wanted to make sure that somebody doesn't, and let's do this, and you wanted to make sure that somebody doesn't accidentally turn that off, and then you run into trouble, what you could do easily enough is you could say if hasatter base foo, you can say raise type error base is improperly provided. So you could do something like that. And so if you have some issue in which you're worried that a base class might change and you want to have a constraint on that, that's quite easy. And the reason that it's quite easy is at the time when you're performing this derivation, when you're deriving from this, base already exists. So you can look at it, you can touch it, you can ask it questions about itself, and you can say, hey, do you conform to the style that I look like? But the other way around is a little bit harder. What you can think is, if you control the base class and you know somebody is going to write a derived class related to you, and you have some constraint that you want to enforce, not from the derived up to the base, but from the base down to the derived. For example, let us say that this, it looks like this. Here, you want to create an instance of this derived class, and you want to call bar on this derived class, and you're worried that the people who are writing these won't implement that correctly. How do you do that? Because at the time in which you write this base class, the derived class doesn't exist yet. And so there are 3 different approaches, and I have 1 minute to show the approaches. The first approach is, if you take a look at the first approach is build class. If you take a look at the built-ins, in the built-ins module, there is a function called build class, and this gives you the ability to introspect and to hook into every single class building operation that occurs in your entire program. So let's see if I can do this. BC. Let's see if that should hook there. And I got to say built-ins here. And here you can see if I do import JSON, here we'll print out the args and the quargs, and you can see every single class definition in the entire program is now intercepted. That is a very, very powerful technique, but it is unwieldy. The other way you could do this is via a meta class. And so what you would do is you'd have base, define a meta class. And this looks like this, and I'll take just a couple of extra seconds. I think I have just a little bit of a grace period, and you could do a new here. This is class name, base is body. I'll print out base meta with a name, and I'll return super new class name base is body, and you'll see it intercepts. Now, the reason why you wouldn't want to do this is, and I don't know if we have an opportunity to talk about this in that much greater depth, but the reason you wouldn't want to do this is super new. Oh, this is type. The reason you wouldn't want to do this is actually kind of difficult to control, because if this layer also added a meta class, then you have to deal with how do you combine the meta classes. And so the popular technique these days is not to use a meta class. It is instead to use a special method added in Python 3.6 in its subclass, which is a little bit easier to manage. And so this will trigger on every creation of every subclass that derives from you. But fundamentally, the meta class is useful because it's a way that you enforce a constraint or a guarantee from a base class down to a derived class, where the other way is very easy. Going down the type hierarchy is very tricky. So I think I took an extra 30 seconds or so on the meta class. Let us move on to our NumPy dot nan, or a regular nan. So it turns out that the NumPy.nan is just a float nan. So if I say from NumPy import nan, this thing is just float nan, right? And it's not just equal to, actually, it won't be equal to it. It'll actually be the float nan, because what I'm going to show you that's kind of interesting about this nan type. Oh, no, it is, isn't it? What is NumPy.nan? Is it a different instance of the nan? Aren't you float nan? Yeah, you should be. Oh, I guess because it's a, yeah, no, it's not. Yeah, it's not, because this is not a singleton object. So it really is just somebody who, they just implemented float nan. But what's interesting about nan is the following. Nan is one of these objects that is not reflexively equal to itself. So if I say x equals float nan, it is definitely the case that x is x, but it is not the case that x is equal to x, because it turns out that nan is an object that looks kind of like this. It has an EQ, and that EQ just returns false. Because it's not a number, it's not equal to anything. It's not even equal to itself, which is why in my first case, I could say, oh, is NumPy.nan equal to float nan? No, it's not equal to anything. And in this case, it's not actually the float nan, because they're just two different instances of this object. It's not being interned, because there really isn't any built-in interning of the CPython interpreter for anything but integers or strings. Now, one interesting thing about this is, if I happen to have a nan value, and I'll just use NumPy.nan, it is not the case that this nan value is equal to itself, even though it's the same underlying object. But if this is a list of nan values, it is equal to itself, because if you take a look, or even a tuple of nan values, I think even a set of nan values, they should all be the same. Yeah, any sort of Python level container of nan values. Now, when we talked about the NumPy and D array, what I told you was that it was a mathematical type that was aware of its contents. What I think is quite interesting is, if this is not a Python collection, a tuple, a list, a set of nan objects, but a NumPy and D array of nans, we see different behavior altogether. If this is an array of nans, this is not equal to itself. In other words, when Python collections compare for equality, what they do is, especially the ordered collections, they look for the first object that is not the same underlying object and then compare for equality on that. So even though the nan is not reflexively equal to itself, a list of nan objects are equal to each other because they have the same contained objects. When we talked about the Python list versus the NumPy and D array, one of the things we said was a distinction between structure-wise operations and element-wise operations, but we can see something very similar occurring here. A Python list of nan values is compared to another list of NaN values in a structure-wise way, not really knowing what the contents are, but just saying, oh, you're a bunch of NaN values. Okay, you're all NaN values. You're all the same underlying objects. You're equal. But a NumPy and D array implicitly always broadcasts some operation. So if you ask two NumPy and D arrays, are you equal to each other? It's going to broadcast that operation on all the contents. It's going to do that element-wise. And it's going to ask each NaN, are you equal to this NaN? And NaN not being equal to anything, even itself, is going to say no. This also ties us to an error that we almost certainly have seen many, many times before. If I have a Python list and I want to say, is this list empty or not? I might say if X is. But if I have a NumPy and D array and I want to ask if it's empty or not, I'm going to see an error. And the error I'm going to see is that the truth value of an array with more than one element is ambiguous. Use any or all. And the reason for that is even this truthiness operation in NumPy is broadcast, has this kind of notion of being able to see the contents of the structure. So it's being broadcast to all the elements. And so what this will give me is it'll give me some structure which has maybe some true values and some false values, and I have to do any or all. Now there's only two common places that you'll run into where if you have a collection type, or at least off the top of my head, where you have a collection type that's either built-in type or in the standard library, or in a popular third-party module, where if you ask this type if it's empty or full, and you won't do it with this PEP8 supported syntax. You actually have to use something special like all. The other would be multiprocessing.q, which by virtue of being potentially in an inconsistent state because it has this concurrency mechanism within it, you actually have to ask, are you empty? Otherwise, you can see there's actually somewhat an asymmetry here. Now, I actually don't mind this asymmetry because when I think about this, a Python collection type is fundamentally different than a NumPy and D array. A Python collection type just represents some program structuring. It represents some way that I'm setting up a set of computations that I'm going to perform, whereas a NumPy and D array represents a computation itself. And I don't really want to mix and match these. In fact, I want to use these in combination, symbiotically with each other. I want to have these Python lists, these Python sets, these Python dictionaries representing the underlying structuring of the computation I'm going to perform, each experiment, and I loop through the experiments and I run the experiment, and the NumPy and D array representing the underlying computational type, the experiment itself. And so it's okay for me to see this asymmetry between determining if this thing is empty or not, and it's okay for me to see this asymmetry in determining whether these things are equal if they happen to contain NaN values. So I think that's numpy.nan. Last on our list, we have Big O. And I suspect this is not the television show, but the asymptotic complexity. So we can actually see consequences of Big O quite easily in Python. I've talked about some of the Python built-in types, and I mentioned the Python set. And let's construct a very large Python set. And so let me actually do this. Import perf counter, and I'll import sleep from context lib, import context manager. I'll create my timed again. Let's do this. Let's start up our perf counter. We'll stop it. We'll go finally. We'll yield here, and then we'll print out the message, and we'll align it a little bit, and we'll say, what is it? Greek capital letter delta T, and we'll say stop minus start 0.2f seconds. There we go. So here's my simple timed mechanism. And I should be able to see some notions of Big O on even the basic Python collection types. For example, if I create a set with a large number of random integers, let me do this with the list first. Let's do rand range because I like rand range better. Actually, no, I'll do rand int because it'll tie out to what I want to. I'll do rand range. I lost precious seconds there deciding whether I want to rand range or rand int. I can't keep going on like this. I got to be more focused. There we go. Let's do this with 10 elements, and let me see if an element is in here. And just to make this timing, and this is the Python list. But just to make this timing fairly consistent, I'll look for an element that I know doesn't exist. And so here, I'll increase this to 100 elements. And what I'll do is I'll do list there. I'll do some program structuring here. So we'll do from NumPy import log space. And I'll do a log space up to 6. So this is the size. So there we go. So I'm going to do a log space like that. So here I get a logarithmic space, and I'll do this with, what is this, 5 samples. There we go. And so here you can see I'm going to do this with increasing sizes, and I'll round these. Let's do this from 0 to 5, maybe. So I'll do this from 1 element, 10 elements-ish. There we go. And I think if I do that, there we go. That's what I wanted. And I'll do the following. For the sake of time, we'll increase the size of this thing, and we'll print out the size. And we'll see how this thing behaves as this thing grows. And we'll check if 2000 is in this structure. With our time structure, we do stop minus start. And I think we have to, okay, that's good. And then why doesn't that show me the timing that I want? So this should show times. Let me double check. I have perf stop minus start. What's up message? That's interesting. Let's make this, maybe I have to make this larger. Maybe I can't see that timing. So what we should see is we should see the complexity of this corresponding to the size of the structure. And so just have to double check and see why it is. Let's do something really quickly with timed. Let's make sure my timer works. Yep, that timer works. So what we should see is we should see the timing of this structure increase as we go. Let's do this. And it may just be that we don't have enough fidelity in this measurement. This may be too small. So let's just make this a little bit bigger. Yeah, there we go. It's just that the thing's too small. And so we're going to have to make this way bigger to see these timings. Oh, you know what we can do? We can give it more decimal points here. So we'll see. Yeah, there we go. You can see as we increase the size of this by 10, the thing gets slower and slower by 10 elements. But when we switch this over to being a set, you can see the timing is consistent. And so you can see very clearly in built-in Python structures, this constant time versus linear time distinction, because if this is a Python list, it may be a little bit tricky because at least the computer that I'm running on is fast enough that I can't see this. So you know what? I'll use perf counter ns, and I'll show you this answer in nanoseconds. And that should give you a very clear view of this big O. You can see, there we go. And you can see linearly the timing increasing as we go. Whereas if I change this to a Python set, which is a machine order type, you can see that timing is constant. So there you go. It's a little hands-on demonstration of a basic notion in asymptotic complexity, that the time of finding something in a human order structure is dependent on the size of the structure. It's a linear relationship. Whereas the time of finding something in a machine ordered structure, like a Python set, is constant, or at least amortized constant. But in this case, since we're not modifying this thing, that amortization cost is not really considered. So there you go, big O notation. And I think I am done with my batch of 5 lightning talks. How did I do, Lauren?
I think that was great, James, but there's still many more to come. What do you have, another 11? So you're about halfway through, a little more than halfway through the alphabet?
Only? Oh, geez.
How are you feeling?
You're generous. I thought this was a good time to tell him he was doing just okay.
I like the alphabet tie in there. Amazing. Well, let's also check in on how the fundraiser is going. I think we're doing okay over there too. We're at $1,000, $1,085. And so we're still trying to meet our stretch goal of $1,750. So donate. If you like what you see, if you don't like what you see, you can also put that in the comments when you donate. Even small amounts count. It'll show your name right up along the bar that says most recent donors. So you're definitely going to want to check that out. So Jane, I think we have some special guests that are logging on.
We do. First up, we're going to hear from Katrina Reel, who is on the board of directors for NumFOCUS and in particular serves as the NumFOCUS treasurer. And after Katrina speaks, we'll hear from Jeff Reback, who is one of the core devs for Pandas. So Katrina, welcome.
Hi, Jane. Thanks so much for having me. I'm really excited to be here. as you mentioned, I'm a board member on NumFOCUS. I'm also the director of data science over at Cloudflare. You can see our wall of entropy behind me. Our team is primarily Python based. Did want to mention I've been using Python for 22 years now. I actually was counting this up recently. And so 22 years of Python and doing everything from, a former developer, open source advocacy, community relations, all of those things like that. I'm very, very excited to represent this community and do everything I can in order to make it successful and a healthy, vibrant place for open source and open science. I did want to mention actually a couple of things. We had talked a little bit about why open source is important and why open science is important. And I think that, not only do we want to support the developers that are a part of this, but we also want to open the conversation with the larger scientific community, which is where I kind of came in more on the scientific side. And so being able to use these tools and have this no barrier to entry way to get into the sciences and have powerful tools that are adopted and supported in order to be able to produce, repeatable science and open science, I think is incredibly important to us just as a community and also as a society. And I do want to mention that, not only are these tools being used, for COVID-19 research, I can say, at least from the Cloudflare perspective, these tools are also being used for, solar and wind hacks, investigations and things like that. They're all over the place. And seeing the power of how these tools are able to affect all of us around us, I think is an important thing for us to do. I also want to take a moment to also talk a little bit about the NumFOCUS PyData initiatives that are our education initiatives, I think are incredibly important to part of the things that NumFOCUS does. And open source in particular, I think is something that people overlook as an educational tool. And somebody like me, being an old precocious graduate student who came in wanting to learn how to code, learning how to understand computers, learning how to understand scientific computing, open source was my gateway into that. And it opened more doors than I care to acknowledge at this point. Being able to read people's code, being able to be coached by some of the best developers I've had the privilege of working with, and being able to be a part of that and share that knowledge with others, I think is something that is really important. And another reason to really give generously to NumFOCUS in order to support the PyData community and make that a healthy community where we can give back. So with that, I'll go ahead and turn it over to Jeff.
Thank you, Katrina. It was great hearing from you. And now, Jeff, would you like to share?
Yes. Hello. So I'm Jeff Freeback. I represent the Pandas project. I personally work at Two Sigma Investments, and we're of course large Pandas users, as well as we consume large parts of the open source ecosystem, and of course we give back as much as we can really to the ecosystem. I've been involved with Pandas and for over 10 years. And actually within NumFOCUS, we've been involved for at least 5 or 6 years, attending many events. I've done, reviews for many events. And I think that, something Katrina touched on was that the ability to have these events, in person, excluding this year, of course, makes for an amazing experience for people to not only network, but to really learn and understand how open source works, how to give back. In particular, the Pandas project, we actually really try to be welcoming to newcomers. We have a ton of contributors who, some are drive-by, of course, but we really like to have repeat contributors and things like that. And as far as NumFOCUS goes, they have backstopped us, from the very beginning. We have recently, actually only recently, begun to receive some funding opportunities from external folks, be it TiDelift or we have several CZI grants, and NumFOCUS has been there all the way. And so I am really honored to be a part of this ecosystem. I mean, part of the reason I think this ecosystem really works is the fact that we have quite a number of projects that really are vibrant and really are interconnected. And in fact, that's the reason to support NumFOCUS, because we want to contribute or continue this vibrancy. We want to make the projects better and interop better. I mean, the worst case scenario is like, a project is just not advancing, and then new Python versions come out and it's just not working. But I think with the support of everyone and the continued support of NumFOCUS, we can really keep these projects going. These are all fairly mature products, and at this point, we definitely want to. We have bugs and we have fixes, but at the same time, we do want to fix any long-standing things that are going on, especially to make the projects interop better.
Jeff, I have a question for you. So the Pandas project has been the recipient of some money from CZI. And for the folks watching at home who are deciding whether or not they want to donate, could you tell them a little bit about where the donated money goes to? Could you talk about the small development grants that Pandas has received, or where some of the development money from CZI has gone?
These are great questions, James. We've received several different funds. So one, for example, we received several grants to improve our documentation. I think documentation is probably one of my most important things I push in any PRs that come. I mean, just being able to find things, extremely important. We've also begun a large amount of effort to improve, we'll call it what we call extension arrays in Pandas. And this is, a big effort to really make things, to decouple a little bit from NumPy. And the reason for that is to, allow high performance, to allow, effective interop. When Pandas was developed, over 10 years ago, the world was a very different place. And so we're trying to modernize Pandas without having to resort to like a version 2 or a version 3. We are really trying to, make the car better in place. And I think so far we've been fairly successful at doing that, and we'll continue to do that. This requires funds. It requires, dedicated time from folks. I happen to have a full-time job, but at the same time, I can use, time, after my job to do it, but not everyone can. And so we're trying to really have folks who can work on Pandas more and more without sacrificing the regular lifestyle.
Hold on a second, Jeff. I think what you just said was, if people watching at home give $5 or $10, it could make the Pandas documentation better. I think that's worth $5, just between you and me.
Well, it could of course make the documentation better. I mean, it's absolutely true though. Every little bit helps. We've had people from all over the world who are able to contribute just a little doc string, improve one single function, put an example in there. It's funny, earlier, this was actually last year, we ran a worldwide sprint, and we had contributions from over 30 countries over a 24-hour period. It was just pretty amazing that these little things can happen, and it can be anybody can do this. That's the cool thing about this. We can really have all these little contributions, they just add up. And that's what the same as with donations, they just add up. A little bit here and there is really helpful.
Thank you, Jeff. And then I've got a question for Katrina. If you're still around, Katrina, I'm wondering if being on the NumFOCUS board has given you maybe insight into the ways that NumFOCUS operates and makes use of the donations and incoming grants that we get.
Sure. Actually, I think it's really interesting to see how things run over on the NumFOCUS side, and especially acting as treasurer has been really interesting to me to see how we service our projects. I just want to mention that, I mean, the overhead that NumFOCUS takes is incredibly low, right? I mean, compared to the amount of services that we're trying to provide for the community and the amount of support that we're trying to give to the community. So money that goes into NumFOCUS really is, the intent is for it to go back into the projects. There's a great responsibility there that, everyone wants to give as much as they possibly can for the betterment of these projects in order to provide as much stability as we can to these projects, right? So I think it's been kind of fascinating, especially as a board member, to feel like, we're seeing where the money is going. We're seeing how people are using it. We're seeing the community coming together. We're seeing people getting better at how to write grants and teaching each other how to be able to get money to fund their open source projects and make them more stable and be able to fund full-time for developers like Jeff was just talking about. It's actually been a really, really rewarding experience. Yeah.
Awesome, thank you.
Katrina and Jeff, are you going to stick around for James's Vim reveal?
Oh, you bet. Yes.
I wouldn't miss it. I've been, I'm not personally a Vim user. I use Emacs, but I'll still, get a few tips.
There's nothing interesting in there.
No, but
Really
I
is.
think we should do that. It was one of our stretch goals, and I think we should do that now before we launch into the next set of letters. What do you think?
I think he needs to give it up.
I'll see if I can bring it up on the screen. I think I just lost my VimRC. But before I bring that up and I reveal this very personal thing to the world, if I could ask, Lauren, could you help share with everybody what our upcoming stretch goals are, what they might get if they donate? We really want folks to donate. We know these tools and these projects are very helpful for you. It really helps the projects, even small amounts, especially small amounts from individual donors. It really means a lot to the projects. It helps fill up the small development grant rounds. We do, Katrina, multiple small development rounds each year. And how many projects per round do we tend to approve grants for? About 10?
I say it's about 10 projects per round. And I mean, we really do our best to fund as much as possible during those small development grant rounds, for sure.
And I think we've done these for almost all of the projects. These are documentation improvements. These are website improvements. These are community events. There are all sorts of things that directly impact the users. And so we really want, if you have the ability for you to donate. If you don't have the ability to donate, we'd love if you could volunteer, as Jeff said, help us out with the documentation, come to a PyData event. But this is a community-sponsored effort. This is an effort that grows stronger as we get support from you out there in the community. Did that buy enough time that I don't have to do my VimRC reveal?
I don't know. Were you opening up your Vim, or
I'm gonna open this up. Hold on. Okay, let's see. There's really nothing interesting in here. Okay.
That's okay. While you're doing that, I actually I've got a couple of trivia questions to announce. So we didn't read the last one on air. It was a Twitter one only. That it was a throwback to the letter B. In which Python version was the built-in breakpoint function added? Does anyone know here? So the answer is 3.7, and our winner on Twitter was Jürgen Gemak. So thank you, Jürgen. And I have a new question for all of you that's going out on Twitter right now. So let's see, NumFOCUS supports more than just Python initiatives. So here's a question about Julia Lang. What year was the Julia project first funded by NumFOCUS? Your answer will be after the next set of questions. And so go ahead and answer us with @DUTC_training, use the hashtag #CJamesSweat, get us that answer. And we will announce the first person to get us that answer correctly on Twitter after this next set of questions, next set of lightning talks.
Okay, I guess I have to share my screen again and show you.
I think you better.
He is for procrastination, it seems.
And S is for sassy, it
sorry.
seems. So let's see, picture in picture. Here you can see my
James, I have a question for you.
Nothing too fancy. I use Pathogen because I haven't bothered to upgrade to any of the newer ones.
Wait, Jeff, did you have a question?
I think there may be some curse words in here, so I'll scroll through really quickly.
I was going to say
curse words will be around. Stupid plugin won't set my tab settings correctly. Why does it keep inserting this or that? I know I've messed with that a couple of times. Oh, look at my undo relevels. I'm like, boy, I really need to have 10,000 levels of undo because, you know, that mistake I made 15 years ago is important. In fact, I even have a plugin for that called Gundu that allows me to view the graph of all of, I updated this 3 hours ago. Yeah, I tried to make my markdown files, Python files. And so you can see, I haven't updated this in a while. Then what else? Oh, there we go. Let's view our VimRC again. Okay, let's see where we were. And then what else do I have in here that's interesting? Line numbers. This is what turns on line numbers on and off. But when I do these kind of presentations, I try to hide everything. There's a plugin here called Goyo that hides all of the extra mechanisms. It's really supposed to be for people who are writing, you know, text or blog posts. There's also a plugin that I use called Limelight that just highlights the current paragraph I'm under. You can see I have, these are my Gundu preferences. I like to move logical lines, not physical lines. I really hated the capital K. I don't care about X mode, apparently. I don't even remember what X mode is all about. Let's see what else is in here. I don't even know what this is from. So I just better remove this. boy, this is like clean up my vimRC instead of revealing it. Anything else? Really tired of, oh, I'm glad I didn't put a bad word here, but I was really, really tired of dealing with the indent settings. And so I found somewhere some random combination of these, and apparently this didn't work for JavaScript code that I was working on. Beyond that, I also have a little bit of custom Python code, which is how that auto runner works. It actually pulls some block of code from a markdown file into a text file, and then I use iNotify to run that. And then you can see I can run code in Python 2.7 in Python. I have some other one of these that I don't really use anymore for running this in Python 3.9 before I had Python 3.9 on this machine. And beyond that, see, there's nothing really too fancy. A couple of different leader commands to turn on white space. I don't even remember what these are. I guess muscle memory at this point. And then a couple of file settings to set specific file types. Nothing private yet. And then some linter settings. I guess I was really interested in using one of these code like linters at one point. And then, wow, I'm really definitely above. This is so old. We're definitely above version 7 of Vim. And then a bunch of other settings I haven't seen in a long time. Boy, this is fascinating. I set the encryption method to Blowfish 2. Ooh, that's really important because I definitely open and close encrypted files in Vim all the time. No idea where this came from. That SQL type default. Definitely don't give me syntax highlighting for MySQL. Not on this computer. And then here's a bunch of these settings for the Goyo plugin. And I think I'm close to the end. MS build files for the time where I was dealing with, I was building Python on Windows and I was using Vim to edit the MS build files. And that's it. That's it. Absolutely fascinating, isn't it? My vimRC, everybody.
So James, I don't know, it was a little bit blurry. Did everyone get that? A little bit fast too.
It was pretty blurry on my end too. I think maybe that was part of his secret plan to maintain the mystery.
I think it was intentional.
I completely agree. I'm a little underwhelmed, James.
I guess if we hit 1750, I'll post my vimRC on Twitter.
Oh,
thank you.
Okay, you heard it here, folks. If James, if we reach our next stretch goal of 1750, James will post his vimRC on Twitter, so you don't have to scroll back through the YouTube live and see it real fast, real blurry.
That's how vimRCs are. They're as somebody on Twitter said, they tend to be dustier than your basement. That's just the nature of it. I challenged Jeff to show us whatever Emacs uses to config itself. I'm sure it's all written in eLisp. I'm sure it's no better than what I had here.
My Emacs is boring, so super boring.
Okay, well, this was an interesting segment. Thank you so much for joining us, Jeff and Katrina. Really fantastic to have you here, and thank you for helping us make this event a success.
Yeah, thanks so much for having us.
Thank you so much.
Jeff, Katrina, any final words to get people at home to donate?
Please give generously. I don't know what else to say. I mean, as part of our year-end funding drive, this is a really big time for us in order to be able to get through this year. As you can imagine, the pandemic has hit us pretty hard, and anything can help us right now. And so, like I said, if you want those pandas docs, I definitely would think you should give us some money.
That's right. And every individual contribution qualifies for the end of year match right now, right? So
Correct.
your contributions go twice as far.
Yep.
Fantastic. Okay, James, are you ready to jump back into the next set of letters? I think we got to kind of keep to a schedule here if we're going to make this 4 hours time limit.
We've got, what, 16 left? No, 11 left. And we have an hour and 26 minutes. So I better get to it.
You better
Give
get
me my
to
letters.
it. All right. Thanks, Jeff and Katrina. Take care.
Thanks so much.
Thank you.
Bye-bye.
Bye.
Should I just go ahead and tell you which ones that I want to do?
Go ahead.
All right. Well, P, we just talked to Jeff. It's going to be for pandas.
Okay.
Q is for Q.
Okay.
Q as in like Quay Way, that kind of Q, not the letter Q.
Okay.
All right. R for range.
Okay.
S for static method.
Okay.
And T is for tuple.
Okay.
Does that sound good, Jane?
Good.
It does. I'm so glad you said tuple and not tuple.
Oh, yeah.
Wait, is there a problem with tuple?
There might be.
Several.
All right. Well, James is getting that ready. You heard it here. Any donation helps. Go ahead and click that donate now button on Tiltify. We're really trying to help NumFOCUS in their end of year giving campaign. Donors over 100 are going to be entered into a giveaway for stickers, and over 500 for a t-shirt. And we're trying to make this stretch goal so that you can see James's Vim RC posted for real in text that you can read on Twitter. So go ahead and help us out with trying to achieve that stretch goal. You ready, James?
Can we say that if we hit the 1250 stretch goal, Jane will say tuple instead of tuple for the next 3 months? And I will be checking in on her to ensure that she is not name tupling anybody, but name tupling them.
I feel like there might be a violation of privacy there somehow. That comes up in private conversation in my home all the time, and I don't know if I want you involved in
Okay.
that.
Okay. Maybe
is going to be really tricky on this.
Well, that's why you use name tuples, not name tuple, then not just a regular tuple. Come on, validation, because okay, we'll get to it in the lightning talk.
We'll get to it.
Okay.
All right, go ahead and share your screen. Take it away. Whew.
Share my screen. Okay, I got to start off with pandas. So let me update my screen here. And let's get started. Let me switch over to my other view, and we'll talk about the pandas. Talk about pandas. So, as we know, Pandas is a NumFOCUS fiscally sponsored project. As Jeff was saying, that one of the things that they've done in Pandas recently is put a lot of work into the extension array type. Pandas is a library that originally started as a bunch of conveniences on top of a NumPy ND array. And we've talked about NumPy already as this kind of restricted computation domain that gives you the ability to view a raw block of memory with some interpretive layer. And I want to show you broadly what Pandas is interesting about, what makes Pandas interesting and what Pandas is all about. And there's one thing that we'll touch upon in just a moment when we touch upon range. So this will actually be split into, or part of the discussion of Pandas will reoccur in one of the later lightning talks. As we know, we have a NumPy ND array, and the NumPy ND array represents some machine-typed contiguous block of values, and it's some mathematical type, so that if we perform operations on this mathematical type, for example, double it actually does an element-wise operation. And what Jeff was talking about was the array type in Pandas, the extension array type. And the Pandas array, as he said, was a desire to remove or to eliminate some of the dependence, the direct dependence on NumPy. And so you can see here I have a Pandas array. Now, when you think about a Pandas array, you might say, well, hold on a second. For the most part, when I'm using Pandas, I really am pretty much okay with using NumPy. So what does the array really add to my life? But one of the most immediate things that the array can add to your life is, if you take a look at this Pandas array, it contains two NaN values, two values indicating that there's some missing data, but it is still an array of N64s, where if we were to try the same thing with a NumPy ND array, what we would see is that it would accidentally have its type coerced to being a float 64. If we look at the D type here, it'll be a float 64 D type. And so one of the things that's missing from the ND array directly is mass integer types. And yes, of course, if you go into numpy.ma, you can import, I can't remember what it's called. So, import numpy.ma, but there is some support for this in NumPy itself. But you can see that the value of pandas here is providing some additional supplementary information on top of your NumPy and DArray. I like to think of pandas as a couple of things. A bunch of conveniences for working with columnar data sets, especially time series data sets, and a set of types that provide you with some business metadata on top of some raw numerical data. And so you can see this immediately in the pandas array. It's providing you some business metadata, namely the ability to mark that some of the data is missing. Now, if you talk about the pandas series, you might say from pandas import series, and we might take some NumPy and DArray, and we might put this into a series. And I'll show you one of the tricks that I really like. No, I'll do that in a moment. You have some pandas series, and you might say, well, what's so interesting about this pandas series? Now, I told you when we talked about the len type that one of the things that you do when you want to implement a method from the Python object model, from the data model, is you want to find the one unique privileged way to express this idea. And so if I do lookup on this series, you might say, okay, there's one privileged way to do the lookup on the series. Whoops, let's remove that. And so here, this gives me the 0th element from the series, or the first element from the series, the second element from the series. But it turns out that a series is interesting because it has an index. And so you can see that this method, this getItem method, is actually ambiguous. It's either potentially looking something up by its position, or it's looking something up by its label. And if it happens to be the case that the labels are also numerical values, then calls like this may be ambiguous. Is this looking up the 0th element, or the element that happens to be at the 0th position? And the slicing notation, in comparison to the direct indexing notation, one of these is implicitly working on the positions, and one of these is implicitly working on the labels. And so what pandas provides you is a base type, the series, which gives you this bimodality of lookup. You can look something up either by its position or by its label, subject to some index. And this index is merely a mechanism by which you turn a key into a location in the structure. And so this is what the lock and ilock are in pandas. The lock is look something up by its labeled position, and the ilock is looking something up by its integer position, by its row number. So this is lookup by its label, and I'd say this is lookup by the label, and this is lookup by the position. If you think about the last major thing, the last major type that's available in pandas, and there are some other types that were there, like the pandas.panel, but that's really been supplanted by the use of xarrays data array. But if you think about pandas data frame, what the data frame gives you is a doubly indexed structure. And so I'm going to show you something kind of cute that I like to do. Let's say this is a data frame containing, say, financial data, and it has some tickers in it. So here we'll put a ticker, but I can't really think of any tickers to populate this with. So what I'm going to do is I'm going to use a NumPy and DArray. I'm going to use choice from NumPy. I'm going to take a choice from ASCII, from the string module. I'll pull an ASCII lowercase. I'll say, give me a choice of all the letters in ASCII lowercase. And I'll say, give this to me in a size of 100 by 2. And then what I want you to do is I want you to look at this as a set of a string with 2 elements in it, and I want you to ravel it. So here we go. We have a data frame, which happens to have some random strings that we generated using NumPy. And so it may often be the case that we may not use, and let's see, do we get that right? And here we want to do ravel, and yep, that should be good. And here we have, this is what I wanted. This is my ticker. There's something going wrong here. I want this to be of size here. I want this like that. And let's see what it went on here. And I think I want to, do I transpose it? No. Okay, I got to remember how I do that. So I guess I forgot how to do that. Okay, and then, yes, I want this to be of this size, 10 by 3. Maybe I want it 3 by 10. And then I want this as, oh, I want this view. That's what I want. I want it to be viewed like this. There we go. Yeah, there we go. So we have a 10 by 4. And you can see I can construct this really quickly all at once with this ND array. Well, what's interesting about this is this structure has an index, and it has another index, the columns. And so what you think is interesting about a pandas data frame is that it's a doubly indexed structure. It's an index down the rows and an index across the columns. And both of these structures are both index types. You can see this range index here is just the numbers from 0 to 1. If this happens to have some, financial data, so we'll do some, just very quickly to wrap this up, we'll do something like this, normal. We'll set this to the size. There we go. Size equals size. So here we have some information here, and we'll do a set index here on this, and we'll set ticker as the index. And here we go. We should have some normally distributed data. It has an index on it. You can see the index is now the string index representing the ticker. The columns are an index representing the columns themselves. And you can think of all the operations you can perform on a data frame as just being some operations that are moving data either within the actual data portion, which you can access like this. This is the block manager representing the underlying data of the structure, or from the index to the columns, or from the columns to the index, or from the index to the data, or from the data to the columns. And these are what your operations like stack, unstack, melt, pivot. That's what those operations really are. They're just ways to interoperate between these three, or to move data around or within these different portions of the structure. And the data frame is really just a doubly indexed structure. It's just a two-dimensional block of data with two indexes, two mechanisms by which you can find either a column position or a row position, either by label or by its numerical ordinal position. So that's pandas for you. Okay, let's go on to our next one, which is the queue. Oh, we're only on number 2. Okay, queues. What is interesting about queues? Well, what's interesting about queues are it's what the only word in the English language where every letter but the first is silent. But one of the things that we can think about is that a Python stack is a pretty decent modeling for something like the Python list is a very interesting, is a very decent modeling for a last in first out structure for a stack. And if you wanted some kind of queue behavior, you might go into the collections module, and you have a collections.deck. And the collections.deck can model either a stack or a queue. And so if I say collections.deck here, I can pop, or I can pop from the left-hand side. And so what I can do is I can use this either as a stack or a queue. Now, one of the things that I think is really interesting is when you look at algorithms like breadth first search or depth first search, they're actually the same underlying algorithm. And the only difference is what is the underlying data structure which you're putting the elements into. In one, you're putting them into a stack, and the other one, you're putting them into a queue. And so there's a way for you to formulate both breadth first search and depth first search as the same algorithm. And let's see if I can do that off the top of my head. I don't know if I can. So let me say that I have some tree, and the tree is represented as a dictionary, where this is kind of your network X style modeling, where the keys are the children. So this is A, and it has a child called B, and let's end it there. And then we'll say that this also has a child called C, and let's make this go a little bit deeper. Actually, let me do this like this. Let's say this has a child called C, and we end it there, and a child called D, and we end it there. So yep, there we go. And then there's a child called E that has a child called F. So there we go. Okay, and so this should be a tree that looks like this. It's got a child B and E, and the child B has a C and D, and the child F has, or the child E has a child F. And so let's see if we can model this. And so this should be like that. No, let's see, this has A and B, put a comma there. There we go. I think that's right. Okay, and let's see if we can do a depth first search and a breadth first search in 2 minutes. So the depth first search should give me A, B, C, D, E, F. And the breadth first search should give me A, B, E, C, D, F. Okay, so actually let me do this simpler. Let me do a level order traversal versus inner order traversal, because that'll be a little bit easier. So a pre-order traversal of this thing would be A, B, C, D, E, F, right? And so we'll take our tree, and we'll make use of yield from. We'll do the following. We'll print out the node that you're at. So we'll print out the current node that you're at, and we'll try this thing on our tree. And we'll start this from the node A. And I did these lowercase. Okay. And then I'll say for child in tree of that node. What I'll do is I will yield from the pre-order of the child of the here like this. And so here I'll yield this, and I think this should give me what I want. And here I can do this in one line. So here we'll go down to here. Okay, there we go, and we'll change. There we go. And this should be child. There we go. And then this says if the child is in the tree, right? This, there we go. And we'll yield from it only if, no, that should be fine. That should be fine. Oh, and I guess we have to go deeper into this thing, right? Yeah. And then we'll say if tree of node. No. Yeah. No, we'll do this just to make our modeling work. There we go. So here we can see A, B, C, D, E, F, A, B, C, D, E, F. That's exactly our pre-order traversal. And our post-order traversal should be basically the same thing. You know, it just depends on where we yield this thing. So I think this should just be our post-order traversal like this. But our level order traversal is actually the same underlying algorithm. It's just that instead of using the implicit function call stack, we use a queue. And so if I were to do a BFS on this tree, what I would expect to do is I'd expect to use a collections.dec. I'd have this represent my state, right? And then I'd say while I have, and I push into this thing, the initial node, I'd say while state, what you do is you take the tree, you take the children from this, keys, you'd extend this thing with your state, and then you would probably pop something out. So you'd say state.pop left, you'll pop something off the left. This is the node that you're going to work on, and then we'll yield this thing. And I think that should give us something there, although I have not done this in a very long time. So we'll see if this works. And if it doesn't, then we might just call it for this lightning talk and see if we can do this. Now we're missing one thing. This should be a deck, not a queue. And the last thing is we have to see if the node is in. Oh, and we have to measure. Ooh, this is okay. So we'll do a tree node like that. That's what we have to do there. And then something like that, maybe. And then here, this gives us the actual underlying object. We pull that out, and then we extend that with the keys. No, we extend this with the items. So this would be the key and the like that. Yeah, this modeling is quite atrocious. So here we want to, we want to extend that there. The modeling of this thing is not that great. So let's see if we can get this done in the remaining couple seconds we have before we have to move on, or we might have to come back to this because we are almost out of time. And so I think we may have to come back to this one with the stack versus queue, because I think we're out of time on this. Wish I could have gotten that one done, but one failed out of all the other ones we've done. Not too bad. Let's move on to the range. And the range is, I think, a little bit easier for us to talk about. What we may find is that there is a consistency in Python with its interval notation. And the interval notation in Python, let's restart. And we're going to talk about interval notation when we talk about range. And so when we see the range object in Python, the range object in Python uses a closed open, a half open interval notation. It goes up to, but does not include its endpoint. So if I try and dump this into a list using my PEP 448 additional unpacking generalizations, I'll see the value 0, but I won't see the value 10. And this consistency of the interval notation is pretty thorough in Python. So for example, before I was deliberating between whether to use randint or randrange. And randint is one of the rare cases in which we see this interval notation not being obeyed. In other words, if we do a randint between 0 and 2, we'll actually see the 2 value. Whereas if we do a randrange between 0 and 2, we'll never see that 2 value. And if we look at the help text for randrange, we'll see that this is explicitly called out in that help text because it says it fixes the problem with randint, which includes the endpoint, and that's not usually what you want in Python. And the exclusion of the endpoint is something that we see quite consistently in Python. For example, in our slicing notation, we can see that if we slice to 3, and I'll make this a little bit clearer. What we can see is we will go up to, but not including the third character. And so you can think this is the 0, first, second, third. We won't include that third character, but I can show you 1 or 2 places where this is not obeyed. From NumPy, import linspace. Linspace will include its endpoint. So this is a linear space with a certain number of samplings. So here I have a linear space with, say, 101 samplings from 0 to 1 to 10. And this will actually include 10 as its endpoint. You can see there. So this is one common place where you'll see that open-close interval notation, in addition to the randint, is not preserved. But this doesn't really represent like a slicing or a subsetting operation. And so we'd expect every time we do a slicing or a subsetting operation, this closed open interval notation would be preserved. But there's another place where we see that it's not preserved. And this goes back to our pandas series. As I said, what's interesting about the pandas series is that the pandas series gives you a bimodality of lookup. You can look up elements either by their position or by their index label. And so here I have a series object with the labels A, B, and C. And if I print this out, you can see it's just 1, 2, and 3 with the labels A, B, and C. And if I slice it using the basic notation here, you can see this is giving me an implicit operation. And actually, let me change this to something like this, 10, 20, 30. You can see this works implicitly on the positions, not on the labels. And you can see this obeys our regular notation of, okay, don't include the endpoint. If I use lock and iLock, I can be a little bit more specific about the modality that I want, whether I want to look things up by its position or it's by its label. And if I do this specifically by the iLock, we can see, okay, everything's hunky-dory, everything's fine. But if I switch this back to my index with non-numeric values, and I do the .lock, and I say, give me this pandas series up to, but including or not including the C, you can see, oh, hold on a second. This iLock, this lock lookup in pandas gives us a closed interval. It's closed on both ends. It includes the endpoint. And this happens irrespective of whether this happens to be a numeric or non-numeric index. And you might wonder, why is that? That's kind of strange, because if, and you can see here, this meant the label 3, and so you can see the label 3 was included. Let me actually make these things match up so you can see that there really is something interesting happening here. We get different values for the lock up to 2 and for the iLock up to 2. It includes the endpoint on the lock accessor. And the reason for that is that lock accessor in pandas looks at the labels of the index. And the labels of the index are not guaranteed to be totally ordered. In fact, the pandas index even knows certain characteristics of itself, like its monotonicity. I think it's like this, monotonic. And this is something that is taken into consideration when you do slicing notation in terms of what are you going to return, a single row or multiple rows. And if the index is not monotonic, certain operations may or may not work on that. Certain slicing operations may or may not work. Certain indexing, all the indexing operations should work. In any case, because the labels of the pandas series are not guaranteed to have a total ordering, and because the labels are not guaranteed to have some natural successive mechanism like numeric values are, like the next value is always a value plus 1, well, the only choice they really had was to implement lock to include the endpoint and to violate this convention that we see in range, rand range, in slicing notation on Python lists, and even the notation in slicing on the iLock accessor. In other words, if we take our series object and we do a lock on this, and it has a value C, we have to include that value, because otherwise it may not be possible for us to say, oh, give me the next value. How do we actually increment this to get to the next value? Whereas if we were to do an iLock accessor, it's always easy to get the endpoint. We just do a +1. And oftentimes when I'm writing code, I may in fact use rand range. And if I wanted to get all the values up to, and including 10, I might write it like this to make it very clear that I understand the open close interval notation. I understand that this won't include the endpoint, but I intend for it to include the endpoint. I intend to go 1 over. And this is why pandas.lock disobeys this interval notation. Okay, that was a little bit better. Let's go next into our static method. And so let's reset our clock. And we'll go into our static method. Now, for the static method, this is one of the common decorators that we see in use on Python classes. So the common decorators that we see in use tend to be what? Property, class method, and static method. And when I told you about the descriptor protocol, when we talked about getAttr, what I showed you was that the descriptor protocol says when you retrieve something from an object, if that thing happens to have a get method, then you do something special. And what you do special is you call the get method with some special arguments. This is how instance methods work in Python. This is how class methods work in Python. But one thing that you might be surprised about in Python is the following. If I do this, if I say create a function foo that takes a self but does not belong to a class, and then I create a class and I say foo equals foo. First, that is very weird. This typically should not work given the way that Python binds variable names, but this will in fact work. And I can do this. Yeah, that works. And I can do this. Import load s. And I can do this. Let's see, what's count? But take a look at this. Let's load from a string. This is a JSON load s. That fails because it says, wait, there's too many arguments that you're passing in, but this works. And the way that static method works is it implements a get, and that get just doesn't really do anything interesting. It's really not that interesting how static method works. What's more interesting is how Python functions work. All functions written in pure Python are in fact things that implement the descriptor protocol. All Python functions implement that descriptor protocol. And so when you have a class and you have a function under that class and you do x of t like this, or x equals t and then x.foo or x.f like this, it's going to look this thing up. It's going to realize it has that get method. It's going to invoke that get method, and that get method is going to put in that self property. That's how the self gets added to Python functions. It's done by the descriptor get function on all functions written in Python. In Python 2, you used to have this bound-unbound method dichotomy. That was eliminated in Python 3. There's no such thing as a bound versus unbound method in Python. In Python 3, it's just that there's a descriptor protocol behind all of your functions that you have. And when you invoke a function, it just goes through the descriptor protocol to insert that self. Well, if we go back to this example, the reason why this works is this function was already a method that could have been bound. And so here, the only little oddity here is something like this really shouldn't work. Typically, there's a distinction between whether this is a local variable or a global variable, and in the body of the class how this is evaluated, managing to get around that. This said, take a function written in another module that happens to be written in pure Python, bring it into the namespace of the class, and now it looks like a method that's on the class, but because it was written in pure Python, it has that descriptor protocol on it, and thus, when I try and invoke it, I'm passing too many arguments because that descriptor protocol will be invoked, put in that self, and it'll say, hold on a second, you want me to do a load s on self? That makes no sense whatsoever. But in this case, at itertools.count, because itertools.count was written in C, the C function did not have the get method on it, did not have that descriptor protocol enabled. And as a consequence, when you look that up on the class, you got just the regular C function back, and it worked perfectly, didn't insert the self argument, and then you could just say next of that. And so you can see that what's interesting about static method isn't really anything. The static method is really just something that says, you know what? My get just doesn't do anything. Just return the function itself. So here you can see self instance owner. This would just say, return self.f, and it won't do anything fancy. So I'll see if I can implement instance method and class method and static method for you directly. Here we say class t, static method def foo, doesn't take any arguments. We'll return foo. We'll create an instance of this thing, and we'll call it. There you go. That's all static method does. And I'll even call it something different so you can see that it is my static method. That's all static method does. And instance methods, here's my instance method. All it does is it binds it sort of like this. There we go. That's all it does. And you can think class method is very similar. So here, this is an instance method. There you go. And if you want a class method, I'll even give you a class method because I have 30 seconds remaining and I'm still upset that I couldn't get the Q one going. We're going to definitely revisit that one, if only for sake of personal pride. And so here, this would just be the owner, I believe, is all that's going to pass through. There you go. So that's something like a class method. the class method, I can't remember if it takes the runtime type. It's either the owner or it's the type of the instance. So I think it takes the runtime type. So I think it's like this. That I have to quickly check. But we're out of time. And so maybe we'll check that in a future lightning talk. And so you can see, if you can, just to put a small note on that, there's a distinction in Python between the static type for where a function is defined and the runtime type of the function that's actually invoking that path. Okay. Lastly, tuples, or as Jane likes to say, tuplays. Or if the folks at home donate enough money, we can make her say, at least for the next month. Bear in mind, she may be on vacation for the next month, and so that might not be as big a win as we'd like, but still, folks at home, let's get donating. Let me restart my timer, and we will talk about the tuple. Oftentimes, I like to ask people about lists and tuples, because I think that really understanding the fundamental types in Python does help us become better Python programmers. And I like to ask them, okay, what is the difference between a list and a tuple? Because I think it really forces somebody to think about what these things actually are, what they mean. In a very similar sense, maybe we'll have time to talk about the difference between a string and a list. And I think this is a very interesting question. It looks like a very silly question. What's the difference between the first option and the second option? Well, obviously one's a string and the other one's a list, but they contain the same data. And so what you can think is the list is that data with some out-of-band structuring mechanism that delimits where one item begins and the other item ends. And the string has some in-band structuring mechanism, namely the commas, that delimit as part of the data, not part of some metadata where one element begins and ends. And if you think about it like that, you can also think that a function that returns 3 values is distinct from a generator that yields 3 values, because the generator is that same computation, but it has an out-of-band structuring mechanism to split that computation into parts. Whereas the function, you really can't tell where part of the one computation ends and the other one begins. And you really can't do anything mechanically with this via the Python interpreter. You can't say, oh, partially evaluate this function. Whereas the generator gives you that structuring, that linear structuring, just like the list gives you linear structuring on the string, and breaks it down into parts that you can then iterate over. But what I'm supposed to show you here is a difference between a list and a tuple. Well, oftentimes people, when they look at that tuple, they say, oh, you know, it's just like a list, except you can't mutate it. And the thing that's most interesting about that tuple is that it is immutable. And I don't think that that's the case, because I think that I can make an immutable list. That's not too hard. Instead of list.append, I would just have something like this. Here's some value, and I just do something like this. Or list.extend, you know, here. And here's some y's, and you know, look, this is always making a copy. And so this is my new list type, and it is immutable. And so clearly, if I can do that, I wonder if in 2 minutes I can show you how to mutate a tuple. That's actually not too hard, because NumPy is a view of memory. What I should be able to do is I should be able to take the, let's give a tuple here, say 1, 2, none, 4, 5. Let's find the ID of the tuple. Let's create a NumPy and D array that's empty. We know where that NumPy and D array sits in memory. So here we can ask this, let's do this, x is equals that. We can take the ID of the tuple, and the NumPy and D array should be earlier on in space. So we'll do array info. We'll take a look at the data, and we'll take a look at 0. And this is the offset between the NumPy and D array and the tuple. And let's see if that's a positive offset. And this is what is this? The array info. What is that called? So that's the array interface. Sorry. Ooh, we should know that. This is the array interface. There we go. And you can see that's the distance between the tuple and where that exists. So what I can do is I can use asstrided to take this thing to make it look much larger than it is. And so here I'll provide the strides. The strides will be 1. I'll say this is now a, and I'll make this an int64, a uint64d type. That'll help me a lot. Equals uint64. We'll make the strides equal to 1, and we'll make the size equal to the offset plus 1. So here, what I can do is I can stretch all the way from where and this is the shape. Yeah, I can stretch all the way from where my NumPy and D array is down to the tuple, where the tuple is. And once I do that, I can take this structure and I can set the strides equal to, and let's go by 1 byte at a time. Let's say 8 bytes. And I think what I want to do is I want to offset this by 3. So I think that's what the header of this structure looks like. So let's see if we can get this to work. And this would be this is going to be from, we're going to go from there all the way to the end. So what we want to do is we want to take this from the offset to the end, and then we're going to say this is 3 elements, I believe. And so this should take us right to the head of this thing. And then once we're at the head of this thing, this should take us to ZS3 like this. Strides equals 1. I think that's what, no, I want strides 8 here, I believe. And then shape should be the length of the tuple. So let's see if that gave us what we wanted. Yeah, there we go. That's the 1, 3, and that's the none value. And I think we have, yep, there we go. We're a little bit far. So I think we take this from, no, let's see, where do we want to go? We're a little bit too far here. So the shape of this thing is at 4. Well, there we go. We can see one of these is this. This here should be the none value that we saw. And so if we do WS of 1 equals the ID of the number 3, then we will either core dump or we'll have updated the tuple. But you can see this technique is a little bit harder to live code than you think, because, oh no, those are the IDs of, so that's going to be the count of this thing. So I think I'm lost a little bit in the object. But what you can see is you can go ahead and mutate this. So there you go. Tuple is not necessarily interesting because it's mutable or immutable. The tuple is interesting because it is something fundamentally different than the list. What that is may have to wait for the next lightning talk. Okay, that was a rush, but I think we got through those.
I think you did. And I think that the audience is responding as well, because we are so close to our next stretch goal. So we're trying to get to 1750 so that James will post his VimRC to Twitter. And we are currently at 1685. We had a couple of big ticket donors as well as some smaller amounts. And so everything counts. If we get to the 1750 goal, remember that these donations go twice as far because they're part of the end of year giving campaign. That's a mouthful, huh? So
Can you
James,
say that one more time? What is this end of year giving campaign?
It's a match. So when you donate $5, it counts as $10. If you donate $20, it counts as $40. So your giving is going twice as far because of a donor match, a corporate match that NumFOCUS has secured for all of their individual donations. So all of your individual your individual contributions today count towards that match.
Well, thanks for reminding us of that. It's
Yeah, of
a
course.
great time of year to make donations. And now I get to introduce our final guest speaker for the day, Tom Caswell, who is a fellow part of the National Lab System. He's out at Brookhaven, and also the BDFL for Matplotlib.
Am I live?
You are.
Go ahead, take it away.
Words, Tom.
Sorry, nothing changed. I wasn't sure if I was on screen. Right. Thank you for having me. Actually, we've recently changed the title of BDFL to Project Lead because BDFL is a funny inside joke, but there's some people when you tell it to, you get very strange looks back. So.
By the way, this just in. I mutated the tuple. I had to do it. I mutated the tuple. I got it working.
Oh, I got James in stereo there. So from the point of view of Matplotlib, NumFOCUS is a giant lever that we can use. So these projects, a lot of them started from individual people, trying to solve their own problems. Matplotlib started with John Hunter trying to make plots to look at EEGs. And over time, these just grew, and you grew this large international team of people who are working on this code. But with really no good home institution, no infrastructure around it. And NumFOCUS is a thing that provides that infrastructure for us. In terms of like really concrete things this provides for us is, even long before the pandemic, like we were fully remote, fully distributed, primarily interacting through text on GitHub and mailing lists. And at some point, we started trying to do regular developer calls once a week. And not having any institution or anything, we were just doing this on like Google Hangouts on personal accounts, which works, but it's very, it's scrappy. And so something that that NumFOCUS has provided for us is access to a corporate Zoom account so that we can make sure those meetings happen every week, independent of who is actually able to show up that week or not. Right? There was, when it was hosted off of my Google account, I couldn't make the meeting one week, and we just didn't have the meeting because I couldn't get on and start the call. Another thing is that we're mostly volunteer, and that gets you pretty far. Like you can do a lot of really good stuff on pure volunteer, but there's some problems that just are better handled by a paid developer. They need more time than a volunteer can put in, or they need 16 hours of dedicated effort, or they're just the kinds of things that aren't fun and that it's hard to get someone excited about doing, like taking care of the CI. And so he's okay, so we should start getting some funding and have paid developers. And this leads to the question of like, so let's assume we get money. What do we do with it? Right? A foundation is not going to write me a check to pay someone they're not, they have rules about how they can spend their money to make sure it gets spent appropriately. And so you need some institution to take that money. If you look at our developer team, we're spread across many institutions across the world. So whose home institution does it go to? Is that home institution going to let that money go back out to pay a contractor? Like, do we have to hire like all of the developers at one institution? It just gets very, as you start looking at this, you get more questions than answers. And NumFOCUS serves that role as as a neutral home institution that can take money from foundations and granting agencies. They can manage our payroll. They handle all the details behind the scenes to make sure that these donations are tax deductible. If you wanted to give me money that just like to me and make it tax deductible, I have no idea how I would do that. And I'm sure there are details behind the scenes that NumFOCUS is taking care of on the finance and business side that I don't even know I don't know. And concretely, so Matplotlib has been lucky enough to get grants from Chan Zuckerberg last year and this year to fund 2 people full-time, Hannah Eisenman working on Matplotlib as her thesis to lay out the foundation for the library going forward, and Elliot Salz-Andre, who's working as a full-time engineer, doing the hard work of maintaining, keeping the lights on and keeping the project going. And that, the process of receiving that money and distributing it back out to the people who need to get it would not have been possible without NumFOCUS. On the smaller side, right, we've also been able to take advantage of the small development grants to great effect. One of the things we funded was Nicolas Rogier to write up some Matplotlib cheat sheets. Nicolas Rogier is probably the best Matplotlib user in the world right now. The stuff he makes is just beautiful. And if you go to github.com/matplotlib/cheat sheets, we have, I think, 4 pages of illustrated examples of how to do things, the basic things you would want with Matplotlib. Another thing we did with the small development grants is we have a fair number of platform-specific bugs, right? So something can be, there's a bug on a Mac that, only shows up on Macs or on Windows, or, and on Linux, depending on what the bug is. Not all of our developers have access to all of those machines. So we have a small development grant that funds a Mac Mini and Mac Stadium that allows all of our developers to get access to a Mac when we need to debug, that sort of thing. And I guess, on a personal level, I think NumFOCUS, being an open source developer can be very isolating. most of our feedback from our users is bug reports or complaints. We get our users, the users communicate with us when they're at their most frustrated, angriest, the library's broken state. And one of the things through attending the PyData events, I remember having a conversation with Brett Cannon a couple of years ago at PyData New York, where I commented on how people walk up and say like, "Oh, the library's great," and you're like, "Are you sure we're talking about the same library? That's not the usual feedback I get." And Brett said, whenever I feel that way, I think to these conferences, you look out and there's 500, 1,000 people here who are all using the tools we built and are very happy. And that on a personal level was very valuable to me to keep going through some of the harsher feedback one receives.
Thank you so much for sharing that, Tom. Yeah, it's true. I mean, I think, Matplotlib is one of the tools that we all depend on, right? And even if there's, another layer on top of it, ultimately, Matplotlib is powering a lot of these tools, right? So I think it's really powerful, and it shows the scale that open source can reach, that, we can say these names like Pandas, Matplotlib, Jupyter, and everyone knows what it is, right? People are interacting with this daily in their work, and it's making a big difference in science. James, Jane, do you have any chit chat for Tom? James, you're muted.
So I absolutely do. So Matplotlib, just like Pandas, is another recipient of small development grants and also a recipient of the Chan Zuckerberg grants. And the larger grants obviously are going to very large scale things. But Tom, could you briefly talk about where some of the money that folks are donating might go to help support Matplotlib? And also, can you teach me how subplots works?
I can teach you how subplots work. And actually, I'm going to do a shameless plug for new features. In 3.2, we got a new layout engine that does a much better job of laying out the subplots. In 3.3, we got Subplot Mosaic, which lets you draw ASCII art representations of your subplots to build uneven grids. And in 3.4, we're going to get a concept of subfigure, which will allow you to do even more deeply nested complex layouts. So in terms of where the small money goes, the cheat sheets are one of the big ones. Those are beautiful, and we need to do a better job of making them known. And just some of the underlying infrastructure stuff that has to happen. So the Mac Stadium Mac, we have a discourse that we self-host on DigitalOcean, and we may need to start paying for some dedicated CI in some cases. And all of those are the sorts of things that would be amenable to a small development grant.
That's fantastic. So it sounds like for the folks at home watching along, if they choose to donate, in addition to getting a copy of my heavily edited and redacted vimRC, and maybe even some other benefits that maybe Tom might provide his Emacs config if we can compel him to. And Tom will also make sure that subplots and the rest of Matplotlib actually works, because Matplotlib can pretty much do everything. And also it can do everything in 2 or 3 distinct different ways to do everything. This money can go to actually make the tools that you use every day easier to use, easier to understand, better documented. This money goes to something that will genuinely benefit not only your life, but the life of the millions of users, the scientists who are using these tools, the data scientists, the physical scientists, the machine learning experts who are using these tools every day.
James, I thought you were also going to mention that we already met our initial stretch goal, which means that all donors today will be included in a very special pull request that you are submitting for a NumFOCUS themed color map to Matplotlib, which may or may not be merged.
It will be. It'll go through the standard review process.
That's the most
I think that's fair.
That's all we can ask for.
Well, and so you do want to make your donation. You don't want to miss out on that opportunity. You don't want to miss out on James's vimRC reveal for real on Twitter. That's only if we meet our 1750 stretch goal. Right now we're at 1685. So, you know, every little bit counts. Every little bit goes to help the projects.
I can throw in my .emacs if that's something that would help move the needle.
Yeah.
Can you show us your RC config? Your RC params, I guess you call it, your matplotlib RC?
I never set an RC params file. Because it is very pragmatic, because if I do, it is possible that I would be masking out behavior users are seeing. So I want to make sure when trying to reproduce bugs, I'm not confusing myself by debugging a different situation than a user's running. But
that seems very reasonable. Okay, I think that James is actually stalling for time because he doesn't want to do the last 6 letters of the alphabet. I do think that we need to probably jump into that quickly. Thank you so much for coming, Tom. It really means a lot to hear directly from the projects, especially the project leads. So really appreciate you coming here today and spending part of your Saturday with us.
Thank you for having me. And please, every little bit helps. Help us help you.
And should we tie your Emacs to the current stretch goal as well?
Sure.
Okay, fantastic. So you will get James's Vim RC, you'll get Tom's Emacs setup, and we'll see how that goes.
And Jane saying to play for a month.
Yeah, and I'll do some
play now. Okay.
Okay. To play. You have to say it very fancily.
Oh yeah, she's gonna say.
I can agree to that. Okay.
And I'll show you my Jupyter setup. How about that? Ooh.
Oh, and I just got a text message from Leah Silent, who is our first guest. Apparently, we have given away, the NumFOCUS board has given $150,000 on small development grants just this year to improve small areas of the projects, small areas that are maybe difficult to find large institutional funding for, as the aforementioned doc improvements, cheat sheets, things like that. $150,000 of SDG funding is what I'm told. And so every little bit helps to improve the projects that you use every day.
It's amazing. Okay, thanks so much, Tom. I'm going to launch directly into, before we announce the final letters, I know that there's some trivia that's been going on in the background. So we had the question about Julia. It was, in what year was the Julia project first funded by NumFOCUS? The answer, of course, is 2014. And our winner on that is, again, Lightseeker on Twitter. Thanks so much for following along and participating. I think we have maybe just the one more trivia question for you. And so this is also going to be posted on Twitter. Reply to us at DUTC_training and use the hashtag CJamesSweat, hashtag CJamesSweat, to answer the following question. What 2-word Easter egg command brings up a poem when using Python? What can you type into your console and get a poem out?
Like an E. Cummings style poem, because it doesn't rhyme, right?
Yeah. Well, you know, so the broader sense of poetry, not like a.
Not the narrow rhyming sense.
Yeah, not in a rhyming sense.
I'm excited to learn the answer to that one.
Yeah, there's many Easter eggs in Python. Are there many Easter eggs in Julia?
I can't think of things like that off the top of my head, but maybe I'm just not in the know.
So I will say this to stall for time. If we hit our next stretch goal, and I don't know what that is, I will write a limerick live, either in this session if we have time or in a future session, about Python. Because you may not know this about me, but I used to spend a lot of my free time writing rhyming poetry.
I did not know that, and actually I've just been informed that we just met our stretch goal of 1750, so I am upping it to 2500. If you want to hear James write a limerick, help us get to 2500. The Vim reveal is coming, the color map is coming, Tom's Emacs is coming. what other things did we promise? We promised the pub quiz is coming. So all of these things have already been achieved and unlocked. Now just
making James seem nuts in front of her coworkers by saying to play for a month. That's coming.
Oh yeah. And definitely Jane's definitely going to do that. So so let's jump into the letters. Are you ready, James, for the last stretch? We're a little bit over time here. It's already 5:45, but I think people will be okay with you going to 6:15.
Okay, I think I can do it. I think I'll go as fast as I can. I'm doing okay on time so far, by the way. And the only disappointment so far is that stupid tree modeling for the Q, the BFS. It's so clumsy, but I got the tuple mutated. And so at least I'm worth that. And so just before we jump into it, I would love to show people my little hacky. I did this live for you on screen. This is how you can mutate a tuple that's supposed to be immutable in NumPy. That's the code right there. The only thing that I was missing is one of the strides should have been 8 instead of 1. And so let me unshare my screen. Let's jump into those last letters and let's do it because I have as much energy as when we started. Lauren, what are my last letters?
Fantastic. U is for underscore.
Okay.
V is for value error.
Okay.
W for walrus.
Okay.
X for X-array.
Okay.
Y is for yield from.
Okay.
And Z, Jane said it earlier today, it's got to be zip.
Okay, so we have zip, yield from. We have, I used yield from in the last one. X-array, walrus for the, I guess that's the, what we call the assignment expression added in Python 3.7, and U for underscore. I got it.
And V for value error. Did you get?
Oh, and V for value error. Yep.
No, they're doing 6 this round. We're gonna finish it off.
Okay, I'm queued up. I'll share my screen and let me switch over. I am ready to go. Okay, underscore. And I have to think of something interesting to say for each of these. So let's jump right into it with U for underscore. Okay. So one of the things that you might have seen in Python code is that sometimes people write code that looks like this. They say for underscore in range 10. You might wonder what that is. And it turns out that there's a convention among Python programmers, namely that the underscore.
Sorry, you gotta start over because we can't see your screen.
Uh-oh.
Just start over from the top. Yeah, share your screen.
I have to remember what I was talking about. What was I talking about again? Okay, U for underscore. So you may have seen before in Python code written by, I guess, Python programmers is what I was saying, is that there is this convention where you'll see code that looks like for underscore in range 10. And this underscore is just a convention that people say in order to indicate that, oh, we don't really care about this variable. Because if you wrote code that looked like this for X in range 10 and you never used X in the loop, then somebody looking at that would be like, hold on a second, why did you care about giving the name to this variable if nobody's actually using it? And so you may find that you might choose an underscore. And similarly with the PEP 448 additional unpacking generalizations, you may see code that looks like this. Here's the head of a list, and then here's the rest of the list. Instead of writing rest like this to unpack the remaining elements, I'll say, you know what, I only care about looking at the very first element of the structure. Or if I only cared about looking about the first element and the last element of the structure, you can see this code very nicely conveys that you're only trying to extract the head and the tail, but not the rest. But the underscore also has another meaning in Python. In the interactive console, here we go, the underscore refers to the last computed expression. And you may be surprised that in your Jupyter Notebook, it's the very same case because Jupyter Notebook uses your IPython kernel. So in other words, if I compute 10 plus 20 and I say this plus 1, that's just the value of the last expression, kind of like that button on your calculator that says ANS. Now, the reason why this exists is, let's say we have some function that is very, very slow. So I'll use my from time import sleep, and we have some function that is very slow, and it sleeps for 2 seconds, and it returns a value. And you call this function, and you're like, oh, darn, I just wasted 2 seconds of my time. I got to call it again because I want this expression. Well, I could say X equals that, but then I'm paying the cost of calling this function again. Or instead, what I could do is I could say, oh, X equals underscore, and then I don't have to waste that time. 2 seconds is not a lot of time to pay, but if you're on the clock for a 5-minute lightning talk, well, it's already a lot. What you might also notice is here I'm using my IPython console, not the REPL that comes with the the REPL that comes with in the standard library, or it comes with CPython itself. And what you might see is on the side of my screen, this in and this out. And you may not have looked really closely what in and out are. Those square brackets are actually indexes. In is a list, a Python list of strings that correspond to all of the input that you have put into your IPython console, or if you happen to be using your Jupyter Notebook with a Python 3 IPython kernel, your Jupyter Notebook. Meaning, if you ever have a cell in your Jupyter Notebook and you accidentally do something in that cell and you delete the content of that cell, but if you've run it at least one time, you can look through this in structure and find all the previous input that you had in the structure. And so here you can see here, these are all the previous lines that I wrote. Now, I'm going to do one quick thing here, and I'll show you something that you might have run into. I'm going to run my IPython under a ulimit with a limited amount of memory. And when I do that, you will see another thing that sometimes catches people up. If I have a NumPy and D array, and that NumPy and D array is very large, and I'm using a Jupyter Notebook especially, because what we know is when we're using our Jupyter Notebook, we oftentimes don't want to use that print statement directly. We'd rather either set our AST interactive mode so that every single uncaptured expression gets printed in that out with a nice pretty format, with a pretty formatting, or we use ipython.display to get that pretty formatting so we can have that HTML formatting on our pandas data frames. Well, what we often do is we'll leave the last expression of the cell to be the thing that we want to look at so that it triggers that really nice formatting. And so instead of writing some code that looks like, normal size equals 10,000 like this, and we print it out to the screen rather than doing a print x's. And when we do that, it gets captured in this out variable. And the out variable is not a set of strings. It's not a list of strings. It is a dictionary mapping the string or the position in the in variable, like in of 3, to the actual Python object of the output, which means if this object is very, very, very large, this out is just a normal dictionary. So if this object is very large and I don't use it anymore, I del x's it, it is still in my memory right here in that out structure. And so if you happen to have a Jupyter Notebook or an IPython console and it seems to get slower and you're loading large pieces of memory, you need to restart it every so often. Maybe the reason is that your out has captured some very large data structure and hasn't cleaned it out. And there is a way that you can clean this out. Do an xdel instead of a del of this structure. And I think I called it, let me create it again. Do an xdel of this structure, and it will be removed from the out as well as any other places that it might have been cached in your IPython or Jupyter Notebook. So that's underscore. Let us move on to our next letter. Our next letter is value error. And let me restart my timer and we'll go right into value error. Okie dokie. Restart. Ready to go. Now, value error is one of the errors that we run into when we have some, when we have some function and we pass in some bad value. And so, for example, what we'll see is if I happen to have some function called mean, and what it's going to do is it's going to compute the mean of a set of numbers just by taking the sum and dividing by the length. And if the structure happens to be empty, what I might do is I might say if not x's, because I'm assuming this is a Python structure, not a NumPy and D array, then I might raise a special error and I might raise a value error. And the reason I might choose a value error is this happens to be the right type of input if this happens to be an empty list. It's just a bad value of that particular type. This will work, but this won't work because it'll be a divide by 0. So I might raise a value error. Value error in itself is not that interesting. You can think of the standard errors that we have. We have things like value error, meaning something passed a value that was bad. We have type error, meaning you pass something that, irrespective of what the value of that type was, it would never have worked. And so, for example, asking for the mean of a string, this is meaningless, right? How do you, it's not a numeric value, that should be a, this should be a value error. And of course here, you can see that should be a type error. But what I think is very interesting to talk about that ties into something that we talked about before is not value error or type error, but key error and index error. Index error a little bit less so. This is the error that we see if we have a Python list and we index it with some index that doesn't exist. But I want to talk to you a little bit about key error. And I want to show you why key error, I think, is the way that it is. If you happen to have a Python dictionary, and in that dictionary, maybe a dictionary like that out that you see in your IPython kernel, if you happen to have a Python dictionary, and in that Python dictionary, you try to look for something that doesn't exist, what does Python do? Well, Python signals that I couldn't find that thing. And you might be aware that in Python, with the Python dictionary, you can do a d.get, and you can get something out. And if it doesn't exist in this thing, it'll be replaced by a default value. And if you don't specify the default value, you'll see a none as a default value. And you might wonder, why is it that Python doesn't use this .get behavior by default? Well, when you think about it, whenever you have a lookup, for a lookup, there's always two possible modes for a lookup. Either you found the thing you were looking for, found it, or you didn't find it. And if you didn't find the thing, there's two ways to signal that you didn't find the thing. You can either signal this in band, or you can signal this out of band. You can either signal this with some particular value, or you can signal this through some other mechanism. If you signal this with some particular value, like is done in JavaScript or even in the shell, for example, you say, okay, I'm going to always return a none value like get does, then it is possible for somebody to mistakenly try to process that value. For example, if I do d.getC, so I can avoid that key error, and then I try and add 1 to it, like I could if I did d.getB, I will see an error, but it'll be a different type of error than the error that I should have seen. Here, it'll be a type error because I can't add none to 1. It'll instead, and what I really probably wanted was a key error, because if I trigger this key error, I'll see the error occur on the line at the place where the error actually occurred. The lookup failed. I couldn't do anything with the result of this lookup. And so it is often the case that when we are working with a dictionary, it may be the case that there is no meaningful way to continue the program's normal mode of operation if you look something up in that dictionary and you can't find it. A canonical example for this would be like an English to Spanish dictionary. You know, if you had a very simple English to Spanish dictionary and you did something with the contents of this dictionary, for example, you looked up an English word and then you wanted to print something out. Here's the corresponding Spanish word. And you wanted to do something with this. You can say, to say the English word in Spanish, you say the Spanish word. There is no way that I can change this from being an in-band from being an out-of-band representation of something being missing. Like if I look up 3 that's not in this dictionary, there's no way for this program to continue running. So if I were to just switch this to the in-band mechanism, the get, the output is garbage. And if I were to try and do something to the output, I have traded one error that should have occurred on this line for another error that occurred on this line. And so what I would say about key error is this. All of these error types and the design of how these exceptions are raised in Python is designed very thoroughly in order to eliminate ambiguities. Don't look at exceptions and say, oh, these are only for exceptional circumstances. Oh, I don't really want to deal with these exceptions. I'll try and find some ways around them. I'll try and swap them out with error codes. Or I'll try to swap them out with error values. Because what you will often find is when you try to do an in-band signaling mechanism for an error like this, it is very easy to either 1, accidentally miss that you got this error, and 2, to properly disambiguate the 2 situations that you found the thing or you didn't find the thing, because it is very much the case in a Python dictionary, even though in this particular sense, it does not, even in this particular case, it does not make sense. It is very much the case that a Python dictionary can contain any object up to and including a none. And so here you would not be able to disambiguate. Did I look the thing up and find it and got a none? Or did I look the thing up and it wasn't there and I got a none? This is why key error exists. This is why dictionaries signal key not found with an out-of-band mechanism using key error, which is related to value error, because that's what I could think of to say that might be interesting about this topic. Let us move on to Walrus. And I'll reset my timer, and then we'll go. Now, the Walrus that Lauren is referring to is something that was added in Python 3.6, which is this assignment expression. As we may know, Python has a statement, has a expression statement dichotomy in its language design and its grammar design. In other words, there are things that are statements, such as defining a function, defining a class. Historically, print was a statement until it became a function in Python 3. Also, things like for loops or while loops. These are all what are called statements. They're things that perform some action. And they are in, and also assignment. So here, assignment is another example. And this is in contrast to things that compute values, like arithmetic expressions or string operations or other method calls, or function calls that compute a value, or indexing operations or lookup operations. These are all things that compute values. Now, it is historically the case that assignment and even what you might call selection were part of the statement side of the language. But Python, quite a while back, sometime in Python 2, added a ternary if-else, which is not just a shorthand form for an if-else. It's not just a shorthand form, but it's actually an introduction of this selection mechanism into the expression language. And so you can say as an expression, x if 2 is greater than 1, else y. Or here, let's do this the other way, x if y mod 2 equals 0. Here you can see this is an if-else that is a expression. Now, for the longest time, people have wanted to have some kind of expression that can bind a variable name. And the reason that they wanted this is as follows. There are cases, and one of the cases that was pointed to was regular expressions. You have some compile from the RE module, and you're trying to match some regular expression. So here's my regular expression, ABC. Here's my pattern. And I want to check to see, maybe I have two patterns. So I have pattern 1. I'll do pat 1 and pat 2. And I have some text. And here I have A, B, C, D, E, F, X, Y, Z. And I want to do something like, for line in text.strip.splitlines. And I want to say for each of these lines, does it match this pattern? So I'll do pat1 dot full match on the line. I'll do match equals pat2 on the line. And I want to do something here. And I'll say, okay, did you match this one? Okay, if this is not none, then you match this one. Otherwise, if you match this one, okay, that's good. But what if I only exclusively want to match one of these two choices? And I want to do that in some order. What if I want to match A, B, C, or D, E, F, or something else, or there's some reason why these overlap? Then I have to write something really ugly. I have to do the else here. Okay, you didn't match here, and then check that. And it starts getting deeper and deeper and uglier as being nested. So let's see. Let's do an import as. There we go. And you can see this just starts getting deeper and deeper, uglier and uglier as you go. And this is full match without the underscore. There you go. So you can see it matched, but I wanted to exclusively match one or the other. Well, this is one of the motivations for creating this assignment expression, what's called the walrus operator. And so what we do is we have some expression that we can do normal expression things. We can check it. We can perform some other operation on it. And so you can see here, we can do this. But this is the initial intentionality of this. And we do an elif, and we can prevent this from being too far nested. Now, I want to show you one thing that I like to do with this walrus operator, because that's the canonical reason. But sometimes when I'm creating like a pandas data frame, because I do a lot of this kind of lightning talk stuff, and I do a lot of live coding, and I do a lot of this for corporate training and for consulting, what I often want to do is generate some kind of random data frame. And one of the ways that I'm going to generate this, just to illustrate a point about some operations you can perform on a data frame, is I'll use NumPy .random, and I'll create a bunch of random one-dimensional NumPy and D arrays. And so maybe these will be normal values. I'll say X normal, and I have to put the size here. And then I have to do, Y and Z. And then later on, I'll say, what, I'm prototyping this. I want to make this 10. I want to make that 10 and make that 10. And so I'll say, oh, why didn't I just do this? And then this here gets ugly and ugly, and I have some line outside. Maybe I'm going to cut and paste this block, but I forgot to cut and paste this up here. Well, why not just use the assignment expression here? So you saw me do this before. Here, I'll say set the size to that, and then do that. And so here you can see this gives me a nice simple way bound within the structure. And I can definitely make this uppercase, but it allows me to cut and paste this block of text, especially if this is like in a Jupyter notebook or something, and move that around. Let me show you. Nope, I think I'm out of time. So there you go. That's the assignment expression, and one little helpful case when you're building NumPy and D arrays where this can be used. Now, moving on, we did walrus. Our next one is X-array. And so I'll restart my timer, and we'll go right into X-array. Now, we are 3 from the end of this set of lightning talks. And so I would implore all of you who are watching, please, if you have the chance and the opportunity, if you are able, please donate. We'd love to meet that stretch goal. We would love to be able to better support these projects. I would love to not have to give you my Vim RC. I think I'm already obligated to do that, but I believe in NumFOCUS and I believe in what we do so much that I'll even show you my Vim RC, which I really, really don't want to, because it's embarrassingly old and embarrassingly full of junk that I haven't cleaned out in years. But it is not embarrassing for you to help out the projects, for you to donate. And so while we get to these last 3 options, if you are watching, if you've enjoyed this, if you're having fun, if you use the projects, please, $5, $10, reach into your pocket, help us out at NumFOCUS, help us support the projects better. Now, that actually was not me stalling for time, because I already know what I want to tell you about Xray. And I'll tell you this about Xray. Xray is a very cool package. Unlike NumPy, which I told you fundamentally allows you to do something that Python couldn't do, that is give you the ability to manage some constrained, some unboxed, contiguous machine type, no dynamic dispatch, content-aware collection. And Pandas gives you the ability to have this bimodality of lookup. You can look things up on 2 axes for a data frame by some index mechanism. So you have some labeled axis and positional axis, plus a million additional conveniences. Xray does not ship with compiled code. Xray doesn't necessarily give you something that NumPy or Pandas or SciPy fundamentally can't give you. It gives you an enormous amount of convenience wrapped on top of these tools. And so what you'll find when you're using Xray is you may often use Xray in conjunction with NumPy and Pandas. And I want to show you a quick little example using Xray. Xray provides 2 fundamental types, the data set and the data array. And the Xray data array is basically just like a NumPy and D array. One of the things that we might do when we deal with a NumPy and D array is we might think of the dimensionality of the NumPy and D array being one of the ways that we can take looping that would exist at a Python level and move it into the restricted computation domain. And so I was recently doing some simulations on something like a chessboard. I was trying to say, okay, what are all the different ways that a chessboard can be orientated? What are all the different ways that the pieces on a chessboard can be situated? What are all the possible end states of a game? What are all the possible beginning states of a game? As just a simple simulation exercise. And since I don't have time to construct this for you nicely, I'll just use random.choice or numpy.random.choice. So I'll simulate a chessboard. And you could think, okay, what does a chessboard look like? I'll say a true or false for a piece being in some space. And I'll say this is of size 8 by 8. So this is my chessboard. And when I do that, okay, I have a chessboard, a simulated chessboard. This is not particularly accurate because if I look at this thing, it's probably got way more pieces than should appear on the board. 31 pieces. That's actually one fewer. Yeah, one fewer than the actual number of pieces. And when I think about this, I might want to distinguish between the different pieces. So I might say, oh, there are 6 different types of pieces. And so here, I add another layer to this that represents the pawns, the rooks, the bishops, the kings, sorry, the knights, the queen, and the king. And when I do that, I might say I want to simulate the board over time. So maybe I want to simulate 30 steps of this board over time. And so when I have my NumPy and D array looks like this, I can ask it certain questions. Like you can say, give me the total number of pieces in the board for one particular block of time. So here we'll sum it over these axes. And so here you can see for each step of the game, these are the total number of pieces. And you can see this is very simulated, so that doesn't really match up. But we don't have the luxury in the remaining 2 minutes that we have to actually pull in real data. And I could do other things like you can say, okay, give me the board for just the pawns for every move. Give me just the pawns for every position on the board, and then perform some other operation on this. And what Xray allows me to do is it allows me to take this NumPy and D array, it allows me to wrap this NumPy and D array with some additional accessors, with some additional conveniences. One of the major conveniences is instead of, and you can see all this code still works, instead of having to access the components of the NumPy and D array as an unnamed tensor, I can actually access the components of this NumPy and D array, the different dimensions, in some named fashion. I can specify the dimensions on this structure. And you can think, what are the dimensions on this? Well, this is the move, this is the piece, this is the x coordinate, and this is the y coordinate. And then notice all of my code still works, except I can now sum over a dimension. I can say sum this over the pieces, the x, and the y. And now this code, what you're looking at is like axis 1, 2, 3. Oh, that actually kind of makes sense. You're giving me all the total pieces for each move, for each position on the board. Here, instead of doing something like this, I could do a selection on this, and I could say select for piece equals 0 for the pawn. But that's not going to work because, oh, that will work actually, but it's not going to work for me because what I want to do instead is I want to give this a coordinate system. And so for the pieces, there's actually a coordinate system here. There's pawn, rook, knight, bishop, queen, and king, like that. And so once I have a coordinate system on this, I can say, oh, give me all of these for the pawn. And once I do that, I can also do some fancy things. Like I can say, give me all the pawns in position x equals 3 and y equals 4, or x equals 3 and 4, and y equals 4 and 6 in that nice little cube for every move in the game. How about that? That's what Xarray gives you. Okay, I think we're on to our second to the end, and I want to give you one more plea. We're so close to the end of this series. We're so close to the end of this telethon. It's the first time we've done a telethon. Help telethon, help us meet our goal. We got 2 more lightning talks to go. Reach into your pocket, see what you can do. Let's talk about yield from. I will restart my timer and let's go. Well, yield from was added to Python as a delegation from a subgenerator, I believe is what it's called. And there were a couple of things that were added in Python that don't really work anymore. One of the cute things that I used to show people was if you had a list that looked like this, it used to be the case in earlier versions of Python, and let's see if I actually have the documentor set up to do this. It used to be the case so you could do the following. Y equals none for g in x's. Actually, let me call this g here, because I used to write this a very specific way. None for g in x's if yield from g and false. So this is how we used to do this. And we'll call this g here. This is some generator. And here I'll print out the results of this. And what I'll do is I'll put this into a comprehension. This won't unfortunately work anymore. You can't put a yield inside a list comprehension, but I believe if I can run this, docker run docker run Python 3.5 maybe. Oh, I have 3 minutes. Let's see if I can pull in this Docker container in the time that I have. And I'll show you this actually used to work in Python 3.5. It's almost there. It's coming. That syntax actually used to work. And it only stopped working fairly recently. It turns out that yield from delegation to a subgenerator can be used in some weird, used to be able to be used in some weird places. And so let's see if that worked. It's coming up in just a moment. Oh, let it come up. And, okay, let's see. I think I gotta run this with probably IT. Whoops. Let's do this with docker run IT Python 3.5 is what I did. Pretty sure that'll work. There we go. And the code I had was g equals 1, 2, 3, 4, 5, 6. And what I thought was kind of neat about this was if you do, what was it, none for g and g if yield from g and false. This used to work. And what this would give you if you flatten this, or if you, none for g and g. Yeah, okay. And if you took a look at this thing, what you would see is it would flatten the list. It was the same thing as writing g for g and g, g for g and g, for g and g, which is the same thing as writing from itertools import chain star g, like that. And so these are other ways that we used to flatten lists and used to be able to use yield from inside the list comprehension syntax. You unfortunately can't do that anymore. And it really upsets me because I used to love this little trick. What yield from is typically used for is you sometimes would have a generator. And what that generator would want to do is it would want to do something like this. Let's say we'd say for x and x's, and you'd want to do something like yield. You want to yield like this. You want to yield inside one of these generators. And so what yield from will do is it will allow you to perform these kind of flattening operations so that a generator can say, okay, I'm going to delegate to another generator and it'll take up for me. So I think I can simulate this for you pretty easily. Let's do this. Let's have this yield 1, yield 2, and yield 3. I can also do a yield from, and I can yield from pretty much anything. So I can do that. So here you go. You can see a little bit about what this behavior is. And yep, there you go. So you can see this is very similar to the yield star in JavaScript. What it's doing is it's saying, don't yield this structure as a structure itself. Go into that structure and yield each individual element. So this thing happened to be another generator. So let's do this here like that. So if this happened to be another generator, you'll see what this does. Okay, if n, there you go. So you can see this used to be very helpful for recursive generators. That's why it came up in my pre-order and post-order traversal. Okay, there we go. I think that's yield from for you. And I believe we are now at zip, the end of our list of things that we want to look at. And so I must implore you in the last 5 minutes that we have together. This is your last opportunity to give, your last opportunity to support the projects. I hope you've enjoyed watching me sweat and suffer. This has not been easy. Yeah, I do this all day for work, but the pressure and the time constraints are pretty intense. And I wrote a bunch of typos. I'm absolutely shocked that more than 10% of the code actually worked. Here is what I will offer you. If we can get up to, I want to say, $2,250. I don't know if we can make it to our stretch goal of $2,500, but if we get up to $2,250, I will take all of the notes for all of the lightning talks and I will put them on Twitter. I'll tweet them out for you so you can see all the notes for all the things that I've written. And if we manage to get to that stretch goal of $2,500, I'll even clean them up and put some extra text around them so you can actually make heads or tails of what the heck I did. But without further ado, let me show you the very last thing that I am going to be live coding for our NumFOCUS 2020 telethon, Zip. Let's talk about Zip. Zip is a iter tool in the standard library. Sorry, Zip is in the built-ins. It's a built-in function that allows you to take two structures and pair them up. And one of the interesting things that comes up when you think about zip is if I take a structure and I zip it with itself, I get itself twice. So if I take 1, 2, and 3 and I zip it with itself, then I just get 1, 1, 2, 2, 3, and 3, 3. And one interesting thing comes up when I do this, which is if I take a structure and I zip it not with itself, but with itself offset by some amount, by 1, then I get a pairwise view. So I get 1, 2, 2, 3. And so here, this gives me some windowed view. And if I zip it with itself offset by 2 like this, and this one offset by 0 like this gives me paired views, or actually windows of size 3 of this structure. And so what that means is, what I could do is I could go into iter tools and I could grab iSlice and T. And I'll grab T because I want to do this on a generator, which doesn't have the ability to rewind to previous states because it's just that iterable and it has that GI frame F last I that we saw. You can't get previous values back out, so you have to T it. You have to make transparent buffered copies. If I take a generator and I T it n times and I enumerate those things and I slice each one of these from some index to the end, then I get one of my favorite little helper functions because I can zip these things together. And this is what I like to call nwise. And what nwise is the ability to get very high, very low overhead or very, I'd say high performance, but nothing in pure Python is really that high performance, but very high performance views of any structure of data that I can iterate over up to and including generators, any kind of stream. And I can get them as windowed views of any size that I want. So there you go. Now, this is not where this ends, because it is often the case that I want to loop over something and do something special for the top of the loop and do something special for the last element of the loop. And when you think about that, well, I can do that in iter tools pretty easily. So I have another helper function I'd like to write called first. And what first does is it repeats the value true n times. It repeats the value false infinitely. It chains these together, and it zips that with some generator. And so that was my nwise. I also have a little helper called first, and what it can do, A, B, C, D, E, and let's actually make this A, B, C, D, E, And here, what I can do is I can look at these values and I can indicate which of them is the first value. It's kind of like enumerate, except instead of giving me the index, it gives me whether it's the first value or not. And when I do that, I might think, well, you know what? Now that I have first, wouldn't it be helpful for me to have last? Well, what I'm going to do is I'm going to write n-wise longest. And I'm not going to use zip for this. I'm going to use zip longest. And the reason I'm going to do that is when you do this zip trick in order to look at something and to look at pairs of something, you also kind of have the ability to look into the future or to look into the past. That's why the zip and this n-wise comes up so often. Anytime I write some code that at the program structure level needs to look into the future, look into the past, then I tend to use zip for that. And I tend to use my n-wise trick. Well, I'm going to write zip longest. I'm going to give it a fill value. And I'll give that fill value some sentinel object. So it's distinguishable from an object that might be in the underlying collection. And last then becomes something quite straightforward. Last is just a lambda or a function that n-wise longests some generator with one more step, so it can look in the future, extracts these elements like this, and maybe I'll give this a sentinel to make this very clear when I'm near the end. And when I'm near the end, just says if this last element is the sentinel, that I'm near the end. And here you can see I have a very nice little high performance structure, an iterator, that tells me if I am nearing the last of some structure without having to materialize it, without having to know ahead of time how big it is, just using zip and the rest of iter tools. Here I'm at the last two, here I'm at the last one, here I'm at the last three, and I can combine these together. And so what I often do is I write loops that look like this. For, and I'll do this in this loop above, for is first, is last, previous value, current value, in first, last, n-wise, A, B, C, D, like this. And then I'll say if we're at the first element, do something special. If we're at the last element, do something special. Otherwise, if we're in the middle, do something special. And this is all built from iter tools and first and zip and zip longest. And I think that's the end of our lightning talks. I'm so surprised that I made it all the way through with only one flub, that Q, which is going to keep me up late tonight. I'm going to have to write that and rewrite that until I can get that to work. But I managed to make it through. I am not breaking a sweat. I'm dry as can be. It's also 16 degrees in here, and I bathed in deodorant last night, or antiperspirant. But I don't think you managed to make me sweat. I'm sorry, Lauren.
Darn, we're going to have to try again next time. But even if we didn't meet our goal of making you sweat, we did meet quite a few of our stretch goals for fundraising for NumFOCUS. So thank you to everyone who contributed. Our final amount right now, there's still time to donate, but our amount right now stands at $21.55 and 1 cent. So we're just $100 away, well, $95 away from that stretch goal that you announced right in the middle of Y, which was
getting all the notes, but not necessarily cleaned up, but all the notes for all the code that we wrote.
That's right. That's right. So if you want to see those notes, go ahead and help us get over the top. We're just trying to get to 2250 would be.
Do we want to tell the audience that the reason why all these went so well was I wrote on my hand for each finger what I was going to type out in code, which is why the Q didn't work, because I only have 20 fingers.
And toes.
And toes.
I thought I saw you checking your foot at some point, actually. Yeah. Yeah. No, that.
And it was kind of blurred. It was like zip, zup. What the heck is that?
Yeah. Well, especially because you were sweating, right?
Yeah.
Were you sweating?
No, it was not.
Fantastic. Jane, why don't you tell us a little bit about everyone that we want to thank today?
Yeah, well, we had a lot of people come together to help make this event happen. I first wanted to thank all of our speakers. So we started off with Leah Silin. We got to hear from her, the executive director of NumFOCUS. After that, we heard from Stefan van der Walt and Wolfgang Kersendorf. So thank you to both of them. Also we heard from Fernando Perez, Travis Oliphant, Katrina Reel, Jeff Reback, and Tom Caswell. So thank you to all of our guest speakers who came to share a little bit about how NumFOCUS is important to them. And we also want to thank the audience for your participation and spending your Saturday afternoon or evening with us. We loved the engagement both over Twitter, answering trivia questions, and of course, we very much appreciate your donations. So thank you so much for spending your day with us.
Speaking of donations, I see they're still rolling in. We're at 2175.01. So thank you for everyone that's continuing to contribute. If you like what you saw today, if you like what you hear about making science more open, more reproducible, more inclusive, about getting better docs for pandas and things like this, if you like that, even little amounts help, and we can try to get to that stretch goal.
And even if you've already made a donation, but you want to push us just a little closer to the stretch goal, I recommend donations of $5.01 for 501c3. If you support 501c3 nonprofits, 501 cents. That's the way to go.
I love it. I love it. I'm getting an announcement about the trivia question that we asked most recently. So what two-word command brings up an Easter egg poem when using Python? And that, of course, is the Zen of Python. And you get it by typing in import this. So you can try it right now, open up your terminal. And if I'm right, you can donate $5.01 in honor of NumFOCUS. Our winner on Twitter is Hypophysis. Hypophysis. Again, I apologize for everyone that I always inevitably mess up your name, but thank you to our winners and to everyone who participated in all of our Twitter giveaways and polls. Also, our
Lauren, I'm told we just hit 2250. Somebody wanted to see those notes.
Yay.
I told you in unpolished form, so you're going to see them just as they are. But yeah, I guess I promised.
Amazing, amazing.
You see, I've dressed down for you as well. I'm now in my NumFOCUS hoodie.
It's beautiful, very casual.
Yeah, very casual.
And I will point out, our numbers did go up just again. So now we're past 2250. We're up a little above 2320. So.
Oh, I have to polish the notes. Okay, my Saturday is going to be ruined now.
You only have to polish the notes if we get to 2,500. So your Saturday night may be safe, James. I don't know. We could.
What am I going to do with the Saturday night? I don't know.
Saturday night.
So if you want to ruin my Saturday night, if you want to make sure that those notes get polished with a little bit of narrative connected text, with a little bit of explanation of what I'm talking about, and maybe I'll fix that Q one because that really bugs me. I probably would be up late tonight anyway fixing that one. Let's get to 2,500. Wow, that's a lot. I didn't think we'd be able to get that high.
Yeah, and what's incredible is that, right now we're at 2330, and if you think about it, it's kind of like 4660 because of that year-end match. So your money is going twice as far with the year-end match that NumFOCUS is offering through their other corporate sponsors. So go ahead and make your donation now. It's going to go twice as far.
Wow.
I'm seeing people on the YouTube chat saying, ruin his Saturday, folks.
Sounds like a hashtag in the making.
What they secretly don't know is that I live for this stuff, don't I? Do I or do I not, Lauren?
Well, yeah, you do. But that's okay. I think we all live for NumFOCUS. We're all here on a Saturday. We're all, volunteering our time to make this happen. We've got a number of people that are not volunteering as well. That this is a sponsored event from Don't Use This Code, but we're here to because we're part of the community and we want to give back. And I think personally this is very important. I've dedicated more hours than I should probably admit to to volunteering for NumFOCUS in various capacities, and it's all because I think it's really important, right? Our future depends on reproducible science, inclusive science, open science, and these tools I think are open science tools and open source tools are really our best path forward in a future that is sometimes terrifying. So to end on that kind of note. Jane, why don't you say something more uplifting?
I have something. I saw that the L silent. who I believe is our executive director from NumFOCUS, the moment we mentioned Ruin James's Saturday, she reached into her pocket and found $50 for that.
Hey,
so that seems to be a seller.
Fantastic. Yeah, right now we're at 24.55, so we are so close to that final stretch goal. That includes the polished notes from James.
Limerick.
The limerick. Don't forget the limerick.
Oh,
I think we even promised
okay,
the
let me start
limerick with
writing this.
James. I think we promised that.
Oh, to play is at 2,500 too.
Oh, and to play.
To play.
To play.
To play.
So that's a lot, you
to
know.
play or not to play.
For $45, I think you guys are going to be getting a lot for that. Yeah, that's all I have. I think it's going to be a lot. Wow, I'm seeing even more donations coming in. So thank you, everyone. We have our raffles to announce as well. I think our most common donor, or sorry, our most frequent donor was David Sushi. Yay, thank you, David, for donating throughout the stream. eFox is asking everyone to now angrily ruin his Saturday. Come on, folks. It is kind of your last chance before we close up this stream. And we are so close. For $45 away.
I'm already writing the limerick right now.
Are you writing the limerick?
I know it's coming. I know it's coming, and I want to save my Sunday.
No, they want to hear from you live.
Okay. Python, a language that's meant. Allow time to be spent.
Are there any other raffles that need to be announced? Oh, I'm getting word that we might have a special guest to bring back on. It looks like Leah is standing by. James, should we bring on Leah?
Yeah, let's bring her back for some final words to thank the audience for this is amazing. We're shocked by the outpouring of support.
And it looks like we are over our 2,500 goal. So incredible. Once we talk to Leah, I think you're going to be on the hook for a lot of things, James. Leah, if you're there, can you turn on your camera? So as we wait for Leah to get signed up, I'm still looking in the chat that we have on the back end here. Who was our highest donor? So I want to give a thank you to Holden for our largest donation of the night. Oh no, well, Holden held it until just recently, and then I see another one for 500. So maybe we can get those details in the support chat, and then I can announce that after Leah speaks. Hi, Leah, great to have you back. What do you think?
Hi. Yeah, it's been a very fun day. Thank you so much. This has been fantastic. James, congrats, you made it through. Yeah, Jane and Lauren, you did an excellent job. And yeah, thanks everyone for their contributions. And yeah, I'm super excited. Met all the goals. Woohoo.
James,
Yeah,
Leah said woohoo, and you're like sitting there.
I'm
polling.
I would love to hear your thought process as you write limerick. So feel free to talk us through the process.
So this one's a little bit rough. Through casual reading.
Working.
But here's what I have so far. I'll share my
working.
screen. I'll switch over to my produced view.
I don't think we need the timer for this one.
So here's what I have so far. Python's a language that's meant to improve how your time is being spent by showing your meaning through casual gleaning and having fun in either event. That's a little rough still. I gotta workshop this a bit.
Oh, that's good. That's impressive.
Way better than I could do.
Wait, did you
Limericks
actually?
are very simplistic, right? They have a very simplistic meter and a very simplistic rhyme scheme. Okay, let me think. So we have to, this is where we need some scansion.
NumFOCUS.
Exactly. They all sound the same, right?
It's the rhythm, yeah.
It's dactylic with a masculine rhyme, I believe.
Yeah. That sounds good.
NumFOCUS supports all the tools. Supports many tools. So fill the air while I keep writing, because this is not an interesting process to watch me write a limerick.
Oh, but it is.
I'm fascinated, personally.
You gotta find something that rhymes with
People
tools.
in the audience are like looking for rhyming words and trying to help you, because I find myself
Focus
automatically doing that as I watch.
NumFOCUS
Yeah,
supports
if
many
you're still
tools.
on the YouTube live stream, if you're still on Twitter, go ahead and tweet at us or send a comment of, you know, various open source rhymes. Okay, we're getting from the chat, NumFOCUS supports many tools. None of you should be fools.
No, see the scan, it doesn't scan.
Yeah,
So
no, it's got to have the pentameter or whatever.
Yeah. That's
Oh, wow. It looks like David Sushi donated again. So thank you for our most frequent donor. And I would also like to call out our highest donors of the evening. So until just a few moments ago, Holden Corral held the highest donor slot. So excited to have support from the Spark community. She is one of the authors of many of the Spark books. And so really excited to see that Holden is here on the line with us, or at least was earlier. And then usurping that spot until just now, we got an amazing $500 from OSS Capital. So thank you, OSS Capital, for making your last minute contribution. Very exciting to see that we raised so much money for open source today. And so now we're at 3170. And
oh, that's great.
Yeah, even though we met our goal, you know, I can post another one. I can make it go to 5,000, right? There's no reason to feel limited by our most recent stretch goal. Donating to NumFOCUS is a great cause and a great place to put your end of year money. So, are we, James, while you're workshopping this, were we also going to do a room reveal? I mean, I think that for 30.
Do you want to see how I live my life? I don't know. That's a bit much. Did we hit our target for that? Or do we want to push that up to 5,000?
5,000. I think it's kind of a lot, but if we get to 3,500, we'll do the room reveal. Meanwhile, you'll just puzzle through this limerick.
Yeah.
How about that?
That one's hard. The problem is I don't know enough about science. So let's see, what are the NumFOCUS projects are. We have projects like TARDIS, which do supernova ejecta. We have Cantera, which is thermodynamic simulation. We do have a molecular, is that MD analysis? That's a molecular analysis project. What is that? I want molecules in here somewhere.
Oh, we can do that.
Molecules. Supernova. Gotta think about that. This is always hard. You have to. The thing with the limerick is you think about it, you dwell on it, and then inspiration hits and it just comes out. And so the workshopping process is kind of finding the rhyme. What's tricky in a really good limerick is finding the joke. You want that through line with the joke in it. So let's try something else. So really the process is not that interesting. NumFOCUS could use your support. Then you have to think what rhymes with support. Exhort. Support.
So James, while you're puzzling through this, I want to ask Leah again a little bit more about how this money will help in 2021, right? There were basically all of the in-person events were canceled this year, right? Not just for your organization, but you know, worldwide everywhere. Things have really had to switch to virtual environments. And I think, what did you have? You had PyData Taipei was in person, because they thankfully got things under control there.
Right, that was it.
Yeah.
Everything else was moved online.
Everything else was online. PyData Global was the first ever virtual PyData, which was really exciting. But you know, I'm sure it was challenging, right? So you go from in-person events to suddenly having to do these virtual events. And how can money raised tonight help you know, the projects in 2021 and also the educational mission of NumFOCUS in 2021?
It's going to help 2021, and I'm working on that budget right now, which is a little bit challenging because we don't know what events are going to look like for 2021, and we also just don't know our corporate sponsorships. You know, it was a challenging year for everyone across the board, both nonprofit organizations as well as you know, seen all across industry in many cases. So our corporate donations were down a bit, as well as taking a hit on the project. So we were carefully watching dollars this year, and that makes it a little bit challenging moving into the next year because we're trying to project and focus those. So having funds to be able to know, you know, we can apply those towards our small development grant program is super helpful. We try to do at least a $20,000 jump every year for small development grants. It's going to be really challenging this year, but we'd love to get that up to like 175 for next year. We hate to turn projects down for small development grants, so we're hoping that yeah, it'd be nice to be able to you know, have the money to be able to see that increase next year. And it was great to hear Tom and Jeff and everyone that came on mention the small development grants. It's so important. People don't realize how important $5,000 can be to a project. And you think, oh, that's nothing. We should be able to get $5,000 for these projects. But like I said, we did 150 this year, and there were still projects that unfortunately we weren't able to fund all the requests.
Well, yeah, I think a lot of people don't realize that even though as a user of open source, like the software is free to download, you know, it doesn't mean that it's just free out of nowhere all up and down, you know, the chain, right? Like somewhere, someone is incurring a cost. Free software isn't free in that sense. It actually takes a lot of money to support these things in the background and to make sure that the strategic improvements that are needed to maintain the projects is really important, right? Because I think it was Jeff Reback that said, you know, if Python keeps advancing but the projects don't, then you know it's you lose the maintainability of something that is very, very critical to a lot of people's work.
Right.
And so NumFOCUS is really important in that, you know, the projects can't take grants directly to themselves. Like, just like Tom was saying, it's not like when Matplotlib needs something, he's able to just, you know, get that money in his bank account and take care of it, right? They need that sort of tax-free status, and that type of governance and the financial structure is what NumFOCUS provides to the projects to help provide a source of, you know, collecting these types of funds like we did today that are not earmarked for anything in particular, that can then go directly to the projects as needs arise in a very strategic way.
Exactly, and to make sure those services are in place that they all need, that we can continue to provide those.
And I love that I felt we heard a pretty consistent message today from some of our speakers about the ways in which NumFOCUS helps to sort of hone developer enthusiasm for working on open source. In that, you know, we have a lot of really talented developers out there that are excited about contributing to open source, and they freely give their time in most cases, basically volunteering and creating tools that then the rest of the world can use. But that sometimes, even small amount of financial incentive is really helpful for people who, need to live. So that's incredibly helpful. And then also the fact that, as Tom Caswell mentioned, that at the end of the day, there are always tiny parts of a project that, people don't want to have to deal with. Whether that's, the accounting or the advertising. Some people, are really enthusiastic about a particular part of a project, but there are always going to be things that need to get done that maybe nobody wants to take on. And by having NumFOCUS there to sort of step up and help out with maybe some of those tasks to kind of keep the infrastructure going and keep things working, those developers who, again, are volunteering their time to create these awesome tools are sort of freed up so that they can focus on the parts that they really enjoy.
Yeah, and I know for me personally, like being part of the open source community has really been a benefit to my career, right? I think Katrina was saying something similar, that, you can see other people's code, you can interact directly with the developers, and you have a community behind you of people that are all working towards a similar goal. I think it's very, very valuable, and particularly to the time that I have spent volunteering for NumFOCUS in my capacity as PyData New York chair in 2018 and 2019, volunteering for PyData Global in 2020. I think all of these things, it really makes you feel like you're a member of the community, and it becomes your network, right? It really helps you out. So I'm incredibly thankful to NumFOCUS, and it's, frankly, an honor that we got to spend this time today raising some money for a cause that I believe in very strongly.
Yeah, I agree. And the communities, it's an incredible community to be a part of. I'm very grateful that I'm able to work with and get to just talk, and work with on a daily basis some incredible people, both the staff at NumFOCUS, all the project leads, users that we meet at events, volunteers. Yeah, that's why coming up on, 9 years later, I'm still here. So very incredible community.
Have I really known you for 9 years? Jeez, it's a long time.
We're coming up to that point.
Yeah.
James, how's the limerick going?
I don't know. See, limericks are a tricky thing. I say when inspiration strikes you, and you have to find that thread or that through line. And one of the things I liked about support as the rhyme was that you could rhyme it against import, which has that dual meaning. And I think a limerick is very good when it has some kind of hidden or dual meaning behind it. And so I'm still workshopping this. It's still taking me a while. This is what I have to start with. I also kind of like the idea of trying to work the project names into it, but it's still a little rough. And so this is going to take me a while. Let's see where we are in the donations. I'll see if I'm on the hook to really wrap this up and come up with limerick number 2, or whether folks are happy with what we have so far, because I'm in it for the long haul. Let's see if the folks at home are too.
Yeah, so currently we've raised $31.70 and 1 cent, which is really exciting.
It's excellent.
That is excellent.
I think it was a fantastic way to spend a Saturday afternoon. Are you still thinking about that limerick?
I'm trying to read it.
I am.
Could you read it for us, James?
Yeah, why don't you read what we have?
There's a couple different ones. As I said, I like the import. I like the duality here of, this thing that we do in Python all the time, and the meaning of this as being important. And I was thinking, is there a way I can put the names of the projects in there? Despite me, I really hate it when people import as. It really bugs me. But whenever you PD import, remember to NF support our projects for sklearning. And then I can't get to the next line. That's a little tricky. I think rhyming with sklearn is a little bit hard. And then you'd have to ropen sigh your wallet. And then we have to find another rhyme. See, the import's a little tricky because you got to find 3 rhyming words with it just to make that work. And so part of the limerick process is also finding what that last rhyme is, so it's not too sing-songy. Like, there's a lot of songs that people, you hear a lot of really bad pop songs, and you have these really simplistic rhyme schemes at the end, like, B and C and things like that. You need to find something a little bit richer than that, but getting just the right rhyme is where you start. So I'd say if there's a process behind it, it's really figuring out what that main rhyme is going to be, and the rest comes together from there. And even though I like that import, I don't know if I can do anything with it, because there's really such little that you can do. You do import, support, exort, comport, but comport is a little bit lofty for a limerick. Let me think. Let me try something else.
So it's 26 lightning talks and a live limerick.
Yeah, and a live limerick.
What a bonus.
And our goal we're trying to hit for is 35, just so that we can wrap up for today.
Yeah, I mean, I think we hit our goals a number of times.
Yeah.
I've bumped it up to 3,500, but I think, actually at this point, if this were real life, I would have like a big check and I would hand it over to Leah and it would say 31.70 and 1 cent, and we'd all go, yay, we did it. Because, originally the goal for this was $750, right? And we blew past that. And I think that this has been really an incredible celebration of everyone. Well, not everyone, we could make it bigger, but everyone in the open source community coming together. And I do hope that we can do this again. I hope we can do this bigger and better next time. Trying to plan this was an event in and of itself. And so I think probably we'll release some of the behind the scenes footage should you guys be interested. But yeah, I hope next time we can get even more of the projects represented. Someone in the YouTube chat even said, it's really the less glamorous parts of NumFOCUS support that benefit the most, right? It's really it's easy to find volunteers for the things that are glamorous, but it's the kinds of things that are really hard to do, or the projects that are a little bit more niche that are still incredibly important, but it's hard to get the support that you need unless we have these kinds of funds for it. So, I don't know, on that note, Leah, thank you so much for joining us this morning, joining us now this evening, at least my local time, your local time as well. And I think we can wrap it up. Thank you so much, everyone that participated in this today.
And when you say everybody who participated, you don't just mean Jane and Leah and all of our special guests, but all of the folks watching from home, even if you didn't donate, just watching, just helping us have a fun time, talk about the projects, talk about what we do with these projects, talk about what NumFOCUS does. All of you are included in this great success. We all did it together. Thank you so much. This is why I wasn't worried. This is why I didn't sweat, because I knew that you all were there supporting us as you have been supporting NumFOCUS and the projects for years. It's been a rough year for many of us. It's been a difficult year for NumFOCUS. It's been a difficult year for folks throughout the world. We are truly blessed to be where we are. We are truly blessed to have a community of users like all of you at home who are willing to help us support the projects, make science better, and make the world a better place. Thank you all.
And thank you to my co-host, Jane, for helping me out here, and for having the same Christmas kind of lights in the background as me, and the hats and the glasses and the gimmicks. It was really a lot of fun.
Thanks so much for having me.
James, there's a request that you read the limerick out loud as it is written. This is everyone's final reminder to donate. If you have a chance, if you got $5 in your pocket, go ahead and put it in the donate button. I believe we announced the raffle winners. Did we announce the raffle winners? If we need to, we will, or we'll follow up on Twitter. And
we'll follow up on Twitter with my Vim config cleaned up.
That's
the
right.
Cleaned up notes.
That's right.
Tom's Emacs RC.
Mm-hmm.
What else do we have?
The color map, the NumFOCUS color map is going to get submitted for a pull request. And you know, continue the conversation here on Twitter or using hashtag #CJamesSweat. You could say, thanks. I saw James Sweat, but then it's going to mess up the hashtag.
Yeah, thanks to everyone again. We're incredibly grateful. And James, yeah, we want to hear you read that.
I hope you all have fun. I hope you all have fun.
No, we're not getting off until you read the limerick, and then that's it. Then
I'm going to go back to my first one. I think that's the best I have. I'm going to have to noodle on this for the rest of the day. Some things come easy when you do them enough, like live coding. Some things you got to really noodle until inspiration strikes, like poetry. I'm going to stick with the first one that I have. But over the next couple of days, I'm going to let this sit in the back of my mind. And maybe I might have something for you in a couple of days when we post all of the other goodies that we have for you. And I'll do that for free because I want to support y'all and I want y'all to have fun. I want you to enjoy yourself just as much as we've all enjoyed ourselves today. So I'll stick with the first one that I wrote. Inspiration struck. I think it's okay. Maybe it needs a little bit of workshopping, but we all know that R, Julia, and Python, fantastic tools. I happen to like Python. That's what I use today. And I like Python because it's a language that's meant to improve how my time's being spent, to show all my meaning through casual gleaning and have fun in either event. Thank you, everybody.
Thank you. Bye, everyone.